think I'm gonna use hand cap today instead of machine cap. One sec. Retrieving the retrieve the webcam. Even I thought then I would do this before I start a stream, but here we are. What's that? And with that said, I'm not actually going to start the camera yet. But right now we only have scribble on my thingy, on my notebook yet. Doesn't do much. I'm explaining what I'm doing. And I don't know why, but the mic sounds so scuffed. Oh well. I deal with that in a later date. Okay, what are we doing today? On the machines are closing the slicer and the web portal for main cell. And on this other screen, I'm gonna put the let's put on the GitHub page. Yeah, that's good. That's not good. Or, yeah, gonna hide the IP cam really quick. I do. No, actually, yeah. Okay. Oh. This is just this stuff. Believe it or not, I scribble. Oh, I see why I was speaking in the mic just now. Apparently, I actually just spelled it out. I was speaking on my mic, so the sound was so compressed coming through. It's so fun. Alright, let's see. Alright, so for today there is two things to be done. The first thing is this one here, which is the I need to finish this. So oh wait, no, I already done it. Oh, okay, never mind. I was gonna tell myself to was it to countersunk the bolt, but then I already done it here at some point. So good job me, I suppose. So that's one last thing to do. So I need to touch this. The next thing is copy and paste that. Copy and save. We put it in. Great. Right, here we go. All right. Right. So let me just refresh the webcam view so you can see what I'm up to. I have been up to. Should there's something illuminating in there? No, nothing to dock myself with. This page is of scribble. Okay. Right, there we are. So we're gonna that way. No, it's bad. We'll get our pencil. So, what I was going to what do you call stream on Wednesday if it wasn't for this thing here. This is the forgot. So yeah, this thing here on the cat view is the bottom half of an active. It's like a filter system. What do it do? I'm calling it the ACTM. And what it does is that it's gonna suck air through a bunch of filter and filter out the air in the chamber and either pump it back into the system or pump it out. Been debating with myself for a while, because now that I've finished the bottom here, and well, the only thing left for this bottom is to chamfer the edges. That's not much work at all. But the thing that I am a little concerned right now, let me just look myself up now. Right, the reason why I was a little hesitant to stream at all on Wednesday, because I haven't thought of how to done the mechanism to direct the air through either one of these ports. So there's there on one port on the left and one port. There's a left port and there's a right port. So as it is right now, the idea is that this port on the left here gonna push air out of the system. Basically, that's a window to the outside, and there's a right port here that for the air to go back in the system. How am I gonna control that is genuinely still something I need to slowly work on. That is what these drawings been for the past few days, trying to figure out what is the best mechanism for all of this. Ultimately, this is what I think gonna end up with here. This is the over center mechanism. Pretty simple, pretty straightforward. Just have a little pin on the back behind the pivot point, and have it toggle back and forth between the two extremes. That's actually something I'm gonna keep. If for nothing else, because the sound of it gonna slapping on one extreme to the other is gonna be nice to have, and it's and the spring tension gonna keep it in place. How to actuate that is the thing that is causing trouble with me thus far. There are purely mechanical ways to do it. I've been drawing a bunch of them. Thought of some push pin kind of mechanism here, for example. That's something that could be used to toggle between them. But ultimately, what I end up with is this. It's simply better off for me to just attach a servo to this and have that thing control the whole thing system electronically, rather than trying to have a purely mechanical means to do so. The tipping point I suppose is that the fact that for there to be the machine gonna try to, you're gonna need to do some mechanical work to toggle it anyway. If I weren't it not if I don't have a servo, that means the motion need to come from somewhere else. Motion, in other words, like either it must come from the existing motors that's already in the system, i.e. if there's some sort of complex serial of if there's a series of steps that the motion need to carry out, specifically to toggle the butt, that is what a purely mechanical system going to entail, and that can be a bit of a challenge for one, and the other and it can also be not so elegant, because the idea thus far all my idea involve either involve the bed moving all the way down the top to stamp on some sort of a switch and open and close the hatch, or it moving X on the X and Y to pull some sort of lever to open the hatch. Neither of which is good, because all of which involve the two head system, the gantry system, to move, and when they do move, sometimes when the gantry need to move, it's involved the potential of causing misstep and broke things on the machine. So I was like, at some point you need to decide. You need to just come to the. I just come to the conclusion that although the servo motor is going to be more expensive than a couple cents of plastic, coupled together wisely, the time that you're gonna take to try to write the documentation for such thing is going to be outweighed by the ease of use of a servo. So that's my ultimate conclusion on that. And yeah, I guess that's what I'm gonna do. As for the servo, luckily for me, I had a Arduino kit back in my uni day, from which I can grab the servo here. Pretty small, so something to test with. I'm not gonna use this at the end, because this one is a 5V, and all my fan is got inside the machine is gonna inside its unit is gonna be 12V. So mixing voltage is not something I'd like to do unless absolutely necessary. Just in case I fry something on the machine. But anyway, I'm gonna connect this to the Raspberry Pi and write some Python script to get it working. Speaking of it, let's see what the cat dragged in. So first we got this bad boy here, and this is from Scott on the Tool Changer Discord. I can see that there's a note for me here, so I'm just gonna take it out and read it first before I show it off to anyone. Let's see, and there's a note more important than that's good in my timeline. Alright, there we go. Lovely. We do it. Make it to Australia. Ah, it's so nice. I don't know if Scott is watching or if he's got consent to it, but I am definitely putting this into a frame, put it on my on a wall somewhere. Oh my god. All right, thanks, Scott. And for those who are wondering what Scott sent me, it's a lot smaller than I thought, and the keyboard is huge too. But oh, a sec, cut the tape here. What Scott sent me? Oh, it's a beacon. It's a beacon probe. I can see that he makes some use of it. Oh yeah, it's revision H2, so it's not cheap at all. God damn. All right, there's a this in case so to make sure that I can be held accountable in case I forget. Scott is gonna be going on the what's it, contributor list. But anyway, I'll definitely gonna use this later when I got the machine. Yeah. Just wrap these up. Don't break anything before you use them. Okay. Besides that, we got that box there, which is first a Pi by 4P. This is something I bought. It came yesterday, so I got myself a Pi 4. But enough, it's gonna stay on my workbench. This is gonna be my test machine, so I can plug things in and out of all these and test out the what do you call, the software the software and how they control the servo and all that, instead of go back and forth to my machine all the time. That was easy. This one by 5. This is going to my machine now. And for the record, for those who are going to build V2 on their own, you don't need this thing. This is a Pi 5, and you don't need it. You really don't. It's overpowered for what we do. But I have one, if for nothing else, because I like the look of this Pacific heat sink here. And honestly, I cannot justify it for any other reason. This thing is overpowered for what we do, like well overpowered. Alright, so that's that. The hardware is rolling in, so get ready to build for my build. Oh, next thing is my camera and oh my god, what did I just do with my model? Oh yeah, I pressed a number or something. Yeah, alright, last thing is the a Pi 02 and a Pi camera. Yeah, these are just for something else. I'm not sure if that is gonna be what is this how these two gonna turn out just yet, but that is gonna be something else. And that's it. Gonna put it all nicely in the box. Make sure that I don't break anything before they can actually be tested. And I'm gonna sit in a corner of my room for a while until I got my machine in. I swear to God, it was fit in for whatever. Oh, there you go. It's just a little. Alright. Oh, don't show my address there. Oops, Daisy. May or may not need to. Not matter anyway. I'm moving out at some point as well. Let me take a sip of my coffee first before I go back to the model. Alright, so I guess the just to get back to the point here, what I am going to do today is not just to deal with the cat, because that's the easy part now. The part that I am pondering for today is actually how the hell am I going to control a servo motor using the GPIO pin on the Raspberry Pi. Because believe it or not, I had never done it before. Well, I used the Arduino to do it before, but I never used the Raspberry Pi to do it before. So I genuinely do not know. So hope you guys dropped in, because that's what I'm up to now today. A lot of videos to see. That. Where's YouTube? There you go. What else am I gonna say? The video here. Hey, learn how to. Oh, what the heck was that? Oh, the stream is already going on. Okay, what am I up to? Yes. So, what I want is. It says couple of server. Raspberry Pi. Raspberry Pi. Yep. Yep, let's just click on one and start watching. Hopefully the sound's fine.
Welcome to another video from explainingcomputers.com. This time it's a kind of stepping stone video, as we're going to learn how to control these things, servo motors, using a Raspberry Pi. This will prove critical in certain upcoming projects, so let's go and get started.
Yes, please.
So,
that's
here we have a servo, or more specifically, this is an SG90 servo, which is the most common type of small servo in the world, and which is often used in things like model boats and aircraft. And SG90s like this are made by many different manufacturers, and I bought this one in a pack of 5 from Amazon Co UK for £8.99, with a similar pack costing $9.99 from Amazon.com. And with each individual servo, you get a set of 3 actuator arms or horns and screws to fasten them to the rotating shaft. Although here I've simply pushed the actuator arm on top, it just goes on like that and stays on pretty well just by a
yeah.
Alright. Fit. That'll be fine for the test purposes in this video. Oh, and I should note it's not a good idea to try and rotate the shaft manually. You could damage the mechanism inside the servo.
Ah, you should have told me that earlier. I've been doing that all day. Oh shite! I might have had a broken servo now.
To explain what a servo is and how it's controlled, it's best to compare a servo to a motor. And so here we have a very small motor with a gearbox on the front, and like all motors, this has got an axle.
That's a lovely motor.
Continuously in one
so
direction
useful.
Or the other, depending on how the power is applied. And to control a motor like this with a Raspberry Pi, we'd need to use a motor controller, such as this L298M, which I've used in previous robotics projects. And when this is all wired up, power for the motor is supplied to the controller, and signals from 2 GPIO pins on the Pi are used to turn the motor either one way or the other.
Okay.
Now, in contrast to a motor, a servo does not spin continuously. Rather, it allows precise control of the angular position of its shaft and actuator arm.
Yeah, I'm just chilling, waiting for the software section.
Inside a servo, there's a motor, some gearing, a potentiometer or other feedback sensor to read the angle of the shaft, and finally, some control electronics. It really is amazing that we get all of this in a tiny case for less than a few pounds or dollars. Now, as you can see, while a motor has 2 wires,
How much is this nowadays?
has 3 wires coming out of it, and 2 of these are positive and negative power leads, which for this SG90 need to supply between 4.8 and 6 volts, with the positive lead being red and the ground rail being brown.
Let's see.
The third orange wire is then used to supply a control signal, which needs to be a pulse width modulation or PMW square wave. Like most analog servos, the SG90 accepts a 50 Hz
that's
square
still
wave,
£8.
so a pulse is
£9.
expected every 0.2 seconds. The angle of the servo is controlled by the length of the positive pulse. The longer the length of the pulse or duty cycle, the larger the angle the servo turns to and attempts to hold itself at. The range of potential values for the duty cycle varies a little between servos, but for my SG90s is from 2 and 12% of the period of the wave, with a 2% duty cycle corresponding to a servo angle of 0 degrees and a 12% duty cycle corresponding to a servo angle of 180 degrees.
Okay.
We'll return to these figures again when we look at our servo control code. As you can see, the wires from an SG90 are terminated in a single 3-pin female connector, and the easiest way to connect this to the pin on a Raspberry Pi is to use a number of these male to female jumper leads, which
I might need
this connector like this. There we
I need to
are.
go buy a whole load of those.
Different GPIO pins on a Raspberry
Or
Pi.
make them. I think I had the connector, but I need to make the wire.
Buy them in ribbons like these, where you can just peel off the ones you want. And as with everything else, I'll provide appropriate links in the video description. Right.
Yeah,
I've now connected our SG90 to a Raspberry Pi, and specifically, this is a Raspberry Pi 3B Plus, which I think remains the most popular model in common use, although you can use any model of Pi. Do note, though, that a Raspberry Pi is not the world's most accurate servo controller, as most of its GPIO pins output software-generated
I got a solution of that
signals,
mechanical
which are
one.
less accurate than those created by dedicated hardware. The Python code modules that we're using in this video also only work with software-generated PWM signals. But for all but the most critical applications, everything will work just fine. As we can see in this diagram, the servo's signal wire is connected to GPIO pin 11, while its negative power wire goes to pin.
Yeah, funny enough, this is not a good idea. You should have used external 5-volt power.
6 and the positive to pin 4, which supplies 5 volts. Usually, servos are powered with an independent power supply, such as a battery pack, with only the control signal and ground rails connected to the Pi. This is because servos can draw a lot of power, which could potentially crash or reset the Pi. However, as we're only using one tiny SG90 servo...
Yeah, that happened to me in my uni days, actually. One of, well, I wasn't the one who in charge of the electronic, but we didn't know that's what servo can do. And so, well, we got a mid-size servo, so one of these bigger one, and on its own, the Raspberry Pi can actually drive these, but only on its own. The moment you plug anything else in, it immediately stops working.
Taking power from the Pi's 5-volt rail should be okay, and I am using a 3-amp power supply here. So let's move from the Pi itself to the desktop. This is a Raspbian, the latest version of Raspbian, Raspbian Buster. And in Raspbian Buster, if we look in the menu under programming, we don't have idle anymore, which I'd like to use in the past. We have to use Thonny, a Python, or at least we could install idle, but I'll use Thonny here because it's pre-installed. So here I'm
Python.
Thonny, there it is. And as you can see, I've got some test.
Alright, so first thing to note here, then this is absolutely a Python code, so that's good. That means I don't need to deviate so far from what I know.
These are the code to control the servo. So what does this do? Well, basically, initially we were importing some libraries, GPIO library.
Let me see. GPIO, Raspberry Pi, yeah, sure. Time, yeah. Oh yeah, that's not too bad.
Time library, because we're going to need those. and we're setting the numbering for a GPIO on the Pi to the board numbering mode, which means the pins are numbered 1, 2, 3, 4, 5, 6 across the board in what I think is the most logical fashion. I always use board numbering. Next, we're setting up pin 11 as an output, board numbering for a GPIO on the Pi to the board numbering mode, which means the pins are numbered 1, 2, 3, 4, 5, 6 across the board in what I think is the most logical fashion. I always use board numbering. Next, we're setting up pin 11 as an output and setting servo 1 as pin level with a PWM control. So
you can connect the servo to IO pin include 7, 11, 12, 13, 15, 16, 18, and 22.
GPIO setup 11, GPIO out, that sets pin 11 as an out.
So set pin out. Set pin 11 as an output. Okay.
Input, and then we're defining servo 1 as a GPIO PWM at 1150. 11 there is the pin, 50 is the pulse frequency, which is 50 Hertz for our analog servo, so that's why we've got 1150.
Okay.
After that, we're going to start PWM running on that pin, but with the pulse turned off. So we're doing servo 1 start, but 0.
Yeah. Now what do I think I can do this in Vim, right? I don't want to dedicate a monitor for my Raspberry Pi. So I reckon what I can do is I just make something in Vim. No, so I can SSH into my Pi and then just do it from Vim, from the terminal.
Have the pulse off, so that means.
But then that also means I need to what do you call? Manually type things in with Vim and all of that, I think. Or Nano.
Nothing's been sent to the server.
Just give it a moment, chat. I can hear the ambulance just running by. Oh, there you go.
To do anything,
Alright, it's over.
drawing power, trying to move things around, it'll simply be waiting to see what's going to happen next. And then after that, we're going to wait for 2 seconds. We're doing a lot of this in this code just so we can keep track of what's going on.
Servo start. Alright, so they initiate the pin. No, so they. Well, but for the first 3 command is literally just to set up the importing the IO pin and then the timing module library. That was easy to understand. Set up the IO board, the GPIO mapping, I suppose. Yeah. And it's also not that difficult to understand. The next one is set pin 11 as an output and set servo 1 as pin 11 as PWM. GPIO setup 11 GP out. Okay, servo 1. Alright. So that's the first line is set up as pin 11 as an output. Okay. And servo 1 equal GPIO PWM. That is the part where they say set up servo 1 as pin 11 as PWM. Servo 1. So next time I see servo 1, that means yeah, you can see the line after the command right after that. Servo 1 dot start 0. Post off. 0 mean off. Okay. You start it and then you put it to sleep.
After that, we're going to move the servo. So let's move down a little bit. There's various bits of code here to move it around a bit to give you a principle. But initially, we're going to rotate it to 180 degrees in 10 steps. 18-degree steps. Why 18-degree steps? I guess it's what I happen to do. It's what this code does. So.
Okay. What about an input, like a switch going on and off? How do we do that? Oh wait, no, because if you remember earlier, there's a GPIO setup 11 GPIO out, so I assume there's a GP setup GPIO dot setup some another number in, right? So I reckon that can you set up as a switch to which then the software can pick up.
Keep track of what's going on. After that, we're going to move the servo. So let's move down a little bit. There's various bits of code here to move it around a bit to give you a principle. But initially, we're going to rotate it to 180 degrees in 10 steps. 18-degree steps. Why 18-degree steps? I guess it's what I happen to do. It's what this code does. So to do this, we're going to define a variable called duty, which is going to be the duty cycle of the PWM signal going into the servo, initially at a value of 2. And down here we've got a while loop, as you can see, and this is basically going to cycle from the values of
that's just a demo
12,
software. I don't need to read
duty
that.
initially 2. It's then going to wait for a second. Duty equals duty plus 1. It'll go back to there. It'll be 3, 4, 5, 6, 7.
Oh, server 1 dot chain duty cycle. Okay, that's just the command they use to control the servo. Time, and the duty 1 is just additional step to keep the while loop going. So that's not much of a problem. Okay. I might want to just flash the Raspberry Pi 4 up and get it up and running really quick, huh? Can I do that? Should I do that? I do have a breadboard. Let's just finish the video. Let's finish the video first.
Through all of those positions, waiting a second between each. After that, we're waiting a couple of seconds more. Why not? It's always good to wait a few seconds. And then after that, a couple of bigger moves. We're going to turn the servo back to 90 degrees by setting servo change duty cycle to 7, which is halfway between 2 and 12, if you think about it. Again, we'll wait a couple of seconds, and then we'll turn back to 0, which is a value of 2. And then finally on the end, always a good idea, very important, clean things up. We'll set the servo to stop. We'll stop the servo, clean up our GPIO pins, and we'll print good.
Turn back to 0 degree.
Bye. So that's what we're going to do. So let's now bring up the servo onto the screen like that, and then we'll run this code. It's very exciting, isn't it? Let's execute the code.
Oh,
we're waiting 2 seconds, and now, yes, it's little steps for starting. It's a bit jittery, isn't it? Let me stop him moving around. And you might see it jitters a bit between the actual stages. It steps there and around now, and again it's a little bit unsafe, a little bit unsteady. What's going on there? Let's just run that code again to show you what's happening. Let's run the code a second time. It'll wait a second and then start doing its steps. But it's sort of hesitating, it's jittering a bit on each step when it gets there, because what the servo is doing is being sent a signal to hold it at a particular position, and therefore its sensor is trying to sense its position there, and then it sometimes isn't quite there, so the servo moves back and forth, it jitters a little bit. How can we get rid of that?
Yeah, that's why I'm gonna keep the over center mechanism on the door, because ultimately I only need the servo to touch and move a actuator pin to a certain position. I don't need it to go the whole way, and having it jittery like that is not very good either. I don't want to use this as a torque to hold the torque.
That jitter, you cry. Well, we could do it using another piece of code, which I happen to have over here. What a surprise. This opens up exactly the same way, libraries and board numbering, setting up the pin, etc., and then waiting for a bit after we've set things up. But now I've altered our little loop, because here we're going to say while duty is less than or equal to 12, and we'll set the duty cycle to be duty, but then we're going to set it to the value, the angle we've asked it to go to, wait for 0.3 seconds, which just gives it time to get there. We're then going to put duty cycle to 0, which is basically no pulse. So basically we move the servo and then we stop moving it. And then we wait for the rest of the time. We were looking to wait for 0.7 seconds here, could be any number you wanted to, and then we'll go through the cycle again. And similarly down here, does exactly the same thing.
That's a while loop.
I'm waiting 0.5, let's let the servo move around. You have to experiment a bit, and it'll wait 4.5 seconds. And down here, again, the same sort of thing, and still clean up on the end. So let's bring the servo back in and run the code again, and hopefully you'll see code.
Yeah, no, so basically this. No, so I know the rough idea on how to set it up and get it up and running, but now I need to figure out the software of compile may also cause jitter. What does that mean?
Another bit of code I've got here, which is servo test code 3. I'll make all of these available to you. Links in the video description if you want to play with this code. This just shows you going to particular angles. So again, we set things up the same way, imported libraries, number, setting up pin, starting, etc. But now what we've got is a bit of code to allow the user to input a value, and the servo will go to that value.
That's what I
So
went
this is an
for.
infinite loop here, and so I put the infinite loop because it says while true is true forever, so this is an infinite loop. I put that inside a try finally setup, and the reason for that is
Surely I can write a code.
so we'll have to break out of it by pressing Control C. And if you use try and finally is always executed even if you break out of a loop. So that just means on the end of this code we'll always stop the servo, clean up the GFIO pins, and of course print goodbye. It's very important to print goodbye on the end of this program. Anyway, back to the important bit, which is the loop here. So while true,
I cannot wait for the MissChanger, although I am on the fence.
For an input. So angle equals float input. Float means it's going to be a floating pointer variable. It's going to be a number rather than a piece of text.
I mean, it's an expensive piece of work.
Servo 1 change duty cycle 2. Angle.
Oh, you're on the fence whether you should get a Trident or a 2.4. Trident. The 2.4 look cool, but I think Trident is more practical.
Over 18 plus 2. If you think about it, that's the code you need because 2 is 0 and 12 is the
where's the input
rotation. So we basically divide by 18 to get the number and add 2 to it.
Angle.
Right angle.
Wait. As a user. Oh, input. How do I burn that into a? How do I combine all that into a like a command, like a function? Yeah, I totally can do that. Yep.
Cool. If that's made any sense at all, it'll work, honestly. Then we're going to wait for 0.5 seconds, then we're going to turn the servo off again to leave it at that position, and of course it'll go back and keep asking for a figure. So if we execute this piece of code, we'll go up here and execute the code. It's come up. Enter an angle between 0 and 180. I've got to think of an angle now. Let's pick 30. It's gone to 30. Let's pick 45. Let's pick 90. Let's pick 135. I'm being very regular, aren't I? Let's pick 67.64. Well, that's exactly right, isn't it? That's good. 180. There we are. Back to 30.
Now, what if I put
0? It's proving a principle, isn't it? And if we press a Control C, it'll come out in a fairly controlled way. So that's nice and good.
But what if I put 181?
Basic code to actually control a single servo using a Raspberry Pi.
All right. I can see that it worked. Obviously, I'm just checking on how easy it is to do the servo thing. You need to make the cat over here first to accept the servo on this little lid. So we just hide that now. That on that lid, not that trapdoor. Yeah, this lid here. I need to make the mount for the servo and then the control arm and all that, and then cable management as well. Oh, so much work. Oh. Should I upgrade from clicky probe to tab? Well, why would you want to upgrade a clicky probe to tab? I think if it worked, then it worked, man. Tab has tab is cool, but you know, if it's not gonna do anything different from clicky probe. If you're gonna upgrade something like clicky, is something that's would be something like what it called beacon. But wait, no, I take it back. For a single tool head machine, tab should allow you, enable you to do a true nozzle probing. So in a sense, that's kind of good, I guess. So if you want that, that's some as we go for. The step upward from tab is gonna be bed scanning, like beacon or cartographer. I never used that one. I don't have that one, so I can't say for this for sure. Cartographer. But anyway, those are beacon. However, they'll have the beacon contact. so you can actually do a true nozzle or probe as well, which is really good. All right, so we have a little mind there just to know how probe work. Oh, I have to take my headphone off. Get back to this thing. Let's finish the cat so that I can actually start dealing with all the electronics. What was I doing? Oh yeah. So I need to design the little flappy doodle. The flappy doodle that controls the airflow. I need to make it now. So I'm gonna put the flap away. Not that flap away, yeah. Enable that object. How do I do this? I reckon. Oh wait, no, I already have the plane here. Alright. Oh wait, no. One of the things that I need to check right now is that drawing. Oh my god. This didn't grow out of control quickly, huh? So one sec, just hide that. Alright, that's the right one. That is the one that we're gonna look at, right? Nope, no, it's not. Where's I need to look up for this one here. I don't know where that is. That one? Ah, it is. So I need to write down some number because this is what the base was designed around. So I need to create that profile, sort of. So what we're looking at, yeah, it's 5 mil in diameter. The length is, oh, for one time you need to put it a radius. I've just put that at dimension, more radius 40, 49.5. For a radius. Tip is 1 mil. Yeah, that's it. I think everything else is gonna fall in line as long as I had the I would put the number in correctly. So close that. Oh, and that gap. Do I want that gap to be 5 mil? I don't think so. I don't think I need that gap to be 5 mil. I need that from there to there to be 5 mil, not there to there. So I'm gonna get rid of that. I think that was a genuine mistake on my part. With that dimension 5. Yeah, so did it broke anything else? Change anything? Nope, that's good. Okay, that's good. Go close that. Oh yeah, it's gonna redraw a lot, huh? Yeah, because I reduced that through there, and then it's gonna affect a bunch of other stuff beneath it as well. But no worries, all is good. So, oh, okay, so I might try and build a MissChanger when I get a Voron to support your work. Oh yeah, no worries, all is good. I'm doing this. I am having fun doing this as much as anyone. So support will be appreciated, but it's not entirely needed if you don't. If you sorry, I'm just trying to focus. If you're doing, if you are not, you can't do it. Don't worry too much. Don't have to force yourself to do anything. This is fun for me anyway. Why am I whispering? God damn it. Feel like some sort of what kind of movie character do whispering? I actually don't know. Whatever. Not a movie buff. Can't put out movie reference. And in the other model, this is a straight line, but now that I'm here, I want to make it an arc so that it doesn't you know, stick out more than I thought it would be. Go a line there, dimension that, make that. Oh, that's a mode. Dimension wrong mode. Ah, make that diameter 5, and the distance between these two are oh, how do I do that? There we go. 1. Okay, the radius of this arc is 9.5. 9.5. That and that should be vertical. Like that. Beautiful. Perfect. Okay. Close that. Extrude it. How did I make the yeah, I made it offset. It's good. Cancel. Extrude that up to that face and reduce it by 0.2. Now we need to check if it's offset the right direction. I don't think it offset the right direction, right? Yeah, no, it's not. Okay, go down. It's not a negative 0.2, it's 0.2. Just 0.2. Yeah, like that. Okay. Alright, that's the flappy doodle. Why is it? Oh, right, because I changed. Okay, one sec. I need to come back to the base really quick because I make some change there and then have cascading effect on things. Like that, put that back on. So the reason why that is because this one got changed, but the next view did not. Oh, come on. Yeah, well, that one. That one did not. So yeah. I can tell, yeah. The it did not settle where it's supposed to be. So that and that dimension is 1. I'm gonna reduce that 1 tad. Well, just to keep the thing looking nice. Close that. Okay. Nice. There we are. Do I miss anything? No, I didn't. It's a very simple object. So we can hide that. Oh my. Hide that. I brushed something, but I didn't think I broke anything. So let's ignore what I just said. Keep moving and trapdoor. Yep. Put a sketch file on because I want to reference the sketch, not the object. Put a hole here and make it 2.9 mil. Yeah, for a 3 mil bolt to come in. Yep. Oh, I'm not sure about that wall, but only one way to find out. That's to print it out in a bit. Yeah. I was saying, yep. Wrong way though. Yeah, I need to print this out to see if this is actually gonna work. But I'll make it 7 actually because 3M36 mil is a very common bolt size. So if I make it 7, that means I give you an extra millimeter to in case something goes wrong. Oh right, okay. But on this side though, because we have that and that, so we need to make an extrusion here. to go out, the whole pin to go all the way up. And then we need to cut a D-shaped groove in it. Yeah, and then we need to cut it into a D shape to so that it can accept a little actuator up here. All right, let's do that. So I'm gonna hide that for now. Put that there. Draw it. Make a random plane. Yeah, just to be safe. And likewise, I'm gonna hide everything so that I can grab my sketch. So, put a oh my god, what just happened? Oh, yeah, and I don't need to do anything. Nice. So extrude it. And grab that object really quick. How far up do we want this to be? This is 5 mil thick. That's actually thicker than we would like actually. Maybe we can't cut it down really. Yeah, I don't want to cut it down because on the other side there is this. You can see from the shadow here. There is already some groove cutting in. So this, if we're gonna reduce the thickness of this panel, the whole thing need to be thinned down because this face need to be remain flat so that it can be printed. So that's annoying. This has come up 10 now, so that little stub there is 10. But if I make it 10, what do you call? First of all, I need a 0.2 or 1 because to make up for the 0.2 that I cut off on the bottom here. But if I 10, oh wait, no, so this is a stud right now is 5, so that can give it 2 mil down, make it 3. How much is 3 mil? Wait, let me grab it. My little ruler here. Yeah, 3 is fine. 3 is fine. Give us some meat. So just reduce. So that stuff is 3, and here it says it's a hole for the bolt that gonna hold the spring in place behind it. Okay. And now I need to cut a groove up here. So I'll make an addendum plane. And I got so many addendum plane for this one simple piece. Can't help it. I hide that, put the sketch back on. So I'm gonna grab it. Right there. Oh, and believe it or not, I actually want that line too. This line here. Because that is going to be the line where everything lay flat on and print it off. Okay. And what the reason why that matter is because I am gonna first grab that. Let me just finish making this. Connect those 2 points. Yeah. And that one, make that parallel. That way we don't have to deal with the layer line cutting across this surface because it's flat with the surface of the print. So now we're just gonna make that like so. Doesn't have to be too exact now because it's very small. It doesn't matter much one way or another. So I reckon at normal time the full length would be 2.5, so I rank it 1.5 is good enough to keep it. This gap need to be 1 mil. Yeah, that's good. And I just realized I need to detect the negative of that, not what I have. But damn it, wrong number. So I need to. Oh no! You need to put this over there so that it doesn't magic.
What?
There we go, like so. .5 0.2 actually. Maybe yeah, 0.4, but 0.4 is good. 0.4 is good. Yeah, make it. I just feel like doing that. Okay, so extrude that. No, cut that. I mean, not all the way though.
Womp womp.
Up. All right. Where's my face? There we go. Up to face. Up to that face. Okay, and that's it. That's a flip. The flap. Gonna swing himself back in and out. Why is this one a little bit bigger? This cut is bigger than it should be right now.
There we go.
And I can't remember why I did that.
Hello. Wow, what?
Uh,
The camera in the right spot?
yeah, this cut
In the right
here.
spot.
You can see that the gap here is there and there is not.
What's up, everyone?
What? Not that much. No, not that much. It shouldn't be that much,
Here's
right?
the thing about
I think I added a millimeter there intentionally, but I can't
prints
remember
don't know
why.
what to do with, 'cause it's like, yeah, okay.
I think it has
did,
something to
like,
do
the
with this gap
calibration cube.
here.
Hey, cool, it
But
prints the
now because I
calibration cube, we all know
dragged the
that.
whole thing back
So
a
it's
couple of
big
millimeters,
printer, so you gotta test it by
and that
printing big
gap there
things.
no longer
So
a
now
big
I
of a
have, like, all
problem.
these
So I reckon I
giant
can
prints
just
that I
remove
have
that
no
last
idea what to do
millimeter,
with.
so I'll get more space
Speaking
here.
of,
Yeah, make it easier to print.
you wanna know what's funny? You wanna
So
know
I'm
what's
gonna
funny?
hide that. Top cut.
This is
that the one?
100%
No,
scale.
that's not the one.
This is 200% scale.
The hell is that hole
And
anyway?
let me just check some numbers here quickly. Home.
And oh no, I remember that. This is the one.
Where is it?
Yeah. See.
How long ago did I print that Deadpool?
So the wedge itself is 49.5. So we'll give it 0.5 off, so we make it 50.
Show me the G code. How long?
50, yeah.
This took 1 less hour to print than
We've got
this.
plenty of space
This
to work with.
took 1
It was
less
meant to be
hour
fair.
to print.
The original number is not that far off either.
Also, red
At the moment,
does
so
not
as
show
soon as
up
we
on
chamfer
any of
this,
my
is
cameras. I don't know
always
if
gonna
it's
fall
just
back
a
in
mixture of
line
the fact
very
that
quickly.
Pixel
So all's
phones
good.
and Sony cameras or what?
All's
But
good.
red just does not like showing up on my cameras. Look at these overhangs.
Wait,
Who
I
said
just
a
realized.
Stoneburner can't
Oh, I don't have any music the whole time. Alright, one sec. Put the music back on. And I definitely do need to check that on your end as well.
Printer's printingly right now. We are printing a,
Okay.
you'll see.
Oh, wait!
You'll
I
see.
have Taylor stream on the whole time in the background.
How's the detail?
Eh.
Twice. It's a point
Alright,
nozzle
my bad,
here.
my bad.
We've gone ahead and put a repeato in here because if you haven't been following, I put out a few shorts about some updates with the printer. Andrew Rogers, $10 for the Friday front. That's right, it is Friday. See how we're getting 42 millimeters cubed a second of flow? Yeah, with the
Good thing
stock
nobody
high,
here
we were not getting 42 millimeters a
But that's
second
it was embarrassing.
flow. We were getting 10.
So just so you know, what I'm doing in the background as I
Let me grab
multitask
the
here is
stock audio,
was
because
I
had
having
to I did not
Taylor
want to
stream
change anything
from
on this
what's
printer.
it the
It
configurator
kind of ruins the point
up,
of
and I'm
reviewing
watching
a
that
kit
at the same
if you
time as I
change
doing
stuff on
this.
the kit. But I literally got to the point where I couldn't functionally use this machine within reason. So it's got a repeato in it now. So this is the hot end that comes with it. It's a sailfish. It's a sailfish hot end. You can see it's got no nozzle in it. So it comes with a 0.4 nozzle, and it was able to print at normal Voron speeds up to.
Yeah, let's hope to dear God that I don't read his comment section and then thought that was my own.
Problem is, the moment I put a
That happened
0.8
before.
CHT in here,
That was so embarrassing that time.
it literally could not handle it. With that much filament flowing
Anyway,
through it, I was printing some.
And
bracket
the
box
unfortunate
somebody
thing
sent me
here
to
for
the
me
mailbox
is that I need to make more part.
One of the reasons I'm printing something tall is to get the gantry up so I can do a panel mod after. But anyways, long story short, I was printing PETG at 250 on the nozzle, watching the heater sit there pegged to the firewall at 100%, and watching the temperature just drop.
So that is flush,
So the
right?
heater was at 100%,
I don't want it flush.
and
Hello,
I just
once
kept
again.
slowing it
And that
down.
was second thought.
Eventually, it like 10 millimeters cubed
Second
a
thought,
second
second
was where
thought.
it was happening. Because
I don't
fun
want it up
fact
to
for those
face.
that don't know,
I want
all
a
3D printer
dimension.
hot ends are liquid cooled. They're
Make
cooled
it
by the
free.
filament flowing through it. So filament flowing through your nozzle, it acts like a heat sink. It takes away heat from the system. And I guess if
may not
this
true.
hot end with the 48,
Oh,
it's
right,
got a
yeah.
40 watt heater, 24 volt. But
If you're
with
watching
so
the
little
stream,
thermal mass
make
to
sure
it,
to like and
the fact that
subscribe.
the
It's
pointed
just
CHP
to
was
help
sticking
out the
past
channel.
socks, so it was in line with the
Yep, totally forgot
hands.
to say that
it
this
just
whole
couldn't
time.
cut it. It just couldn't cut
Know
it.
what I
It
mean?
was
I
a-
am
it
totally
was
a
struggle button.
YouTuber. Totally.
So yeah, so I ripped it out and I put a CHT in there, which means I can now do the El Bancho Grande. So if all goes well, I got to do an order with Polymaker to get some big chungus spools of filament. Speaking of Polymaker, do you want to win a spool of filament? We're going to give one away at the end of stream. Enter for your chance. Link in the video description. I'm going to do an El Bancho Grande after, once I get some big spools of filament, because I haven't actually sliced it to see how big of a spool
It's stream still sounding. No, oh my god damn it. It was still on the whole time in the background, so I was listening to his stream from to this stream. Me and my big brain, man. Me and my big brain. Okay. I think I saw that little problem of mine. I'm totally not distracted. Totally. And I'm gonna turn the music back on. What about to? Okay. Right. So we have the flappy doodles. I think I'm gonna put this flappy doodle on a print right now. Yeah, just to test out. The two things that I want to test out here is this hole, how well it's gonna hold up when I put a screw in there, and I want to see how well this screw came out. Do I have enough filament to print out the whole thing? I think I do have enough filament to print out the whole thing, but not today. I might want to do that. I'm just opening the software here. Give me a moment. Okay. Alright. Oh yeah, actually, this we can open. What the heck is that camera view? Hello? One sec. Okay. So this outer window, let's make it the cruiser slicer. Yep. Okay. So you guys keep popping over the place. Hello. Nice one. Damn it. And now the thing is bugged, so I need to go and use. Oh, there we go. Up. Come on. God damn it. Man. Look, Pablo is Alright, I get it now. I get it now. I understand what the problem is. Yo, Vin. Hey, Duke can do. It can do. God damn it. Okay, okay. I got too distracted. Alright, so this guy need to be printed on oh wait, yep. Alright. Flat, simple. Yeah, you see why I cut the groove out in the exact orientation that I did before. So now that is not like multiple layers, just one layer. It's rest stop right there. So okay, so I'm just gonna export this, put it into desktop, and I can hide this one. Oh, and I can turn the camera on. So is it? It's not recording. Okay. It's not running. Return time. There we go. Oh. It's finished. It's finished what I was meant to do. I turn the lights on. Go up. Yeah. Upload friend. Put that thing in. Yep. Flappy doodle. One flappy doodle coming up. Okay, so while that is being printed, I am contemplating this giant piece here now. Oh wait, no, I don't contemplate it. I need to make the second thing that is relevant to this, and that is what is it called? The motion arm. Motion arm? That's not a goddamn. It's turnkey thingy. I'm gonna print out this whole bottom bit out, I think, at some point. I have to, but the reason why I'm resisting it right now because I know for a fact that I need to come in and finish off and chamfer these edges, and I hadn't got around to do it, obviously. And oh yeah, and also I need to reduce the length of the. Now I will increase that little groove there. You can see it. That was there. That's like 2mm, 2 or 4mm for a nut for a bolt to bite on and hold on to the fan on the other side. But then I realized after a while, it's like I don't need it to be this shallow. I can make it very long and use a long bolt instead. Oh, this is gonna take a while. This whole piece is huge. It's what 280 by 75mm wide and deep. So that's why I've been resisting printing this out. But at this point, I think I ran out of other things to test for a while. So I think I'm gonna put this on a print for a couple of days. It cannot be that long. Okay, and part of the reason why I was resisting it because I don't even have the fan or I have the servo, but I don't have the fan or anything else to strap to it. Oh wait, I totally forgot. This needs hose. Too late. Need to make it anyway. Yeah, let's make it then figure it out. Alright, well that's doing its thing on that right now. Machine is doing it. Eh? Oh, he's huge. Okay. It is huge. Okay. Would this thing fit on a 300 mil bed? I think so, but let's check. Let's check. It's too wide, so you can't put it in it. Diagonal may not work. But yeah, it's 275. That's fine. So it should fit on a 300 mil bed. One sec. I'm just gonna check. There's that selection. Alright. Come on. Slice that. How long would it gonna take? If I do no more setting. Oh, 14 hours. Oh, that. Yeah. I got how much material though? 300 grams. Not bad. Not bad. I got plenty of of material, I suppose. Yeah, one last look. Yeah, let the door thingy go finish, and then I'll put this on, and I think I'll finish. Oh wait, hello. What is that? All right, just open it wide here. So just so that we have a good view of everything. Yeah, I'm just move the window around so you guys can see it too. That way, means that way. That angle there, it's extreme. You can see it. Yeah, that angle there is extremely steep. Might need it. Oh yeah, there we go. Some stability problem there on that angle. Anywhere else do I need? That's not gonna work. Gonna put some support there now. Okay, support it is. Thing we check. Good thing we check. Oh yeah. So that's that. It recognizes it too. It just paint on support everywhere. Oh man. I think what I'm gonna do with this actually is that I'm gonna put on tree support, just so that it's easier to break apart, right? Hopefully. Slice. No, don't do slide. Do it organically. Why is it so sketchy? Why is it so sketchy? Also, you don't need that. I think, yeah, I don't need that. This is built the tree support inside though? Yes, that's, oh, come on. What? Why are you putting tree support? Why are you so keen to put support there? Hello? Can't see it. I'm not sure the bit in the center there is something we want. Yeah, that one is something I maybe not want, but I think I'll keep it for now. See how that goes first. That I don't need support for. That is not needed either. I think the only place that actually needs support is that overhang there. Yeah. How long was that, the other one? The other one is 40 minutes. Yeah, so I'll get this one finished, and then we'll put that one on. Yeah, these are obsessive. Cool. Oh, resale just now not showing up anymore. There we go. Oh my god, it's still broken the goddamn bed. Whatever. Yeah. So, I'm gonna put a note down here. Support second fan entry. Oh, support fan entry. Yeah. Built-in support fan entry. Fan entry. Output groove. How do I spell groove? I don't actually know how to spell groove. Yeah, it's something geo. I put a G-O-R-O, and that's it. Not interested to go look for that. Alright. That's enough. So, now that I can do something, I think I can hide this now. Yeah, I don't know how to spell groove, but okay. Alright, so this is the moment now. Bar. Yeah, let's call it moment on. It sounds cool. Motion on. Yeah. Motion on. This is the thing that so this is the thing that going to have the we're gonna connect it to that little extrusion of it on a trap door and get the rubber band or spring. Haven't decided on which one just yet. To toggle it back and forth. So to do that, I need the trapdoor itself, that's for sure. So put that in, and I need the output top. I want to know now what the distance is. 2.8. Still good enough. That's a hole for the mounting point for the spring thingy. That's good. So I reckon I'll draw something on top of that. Make that a addendum plane. I really need to make the addendum plane a different color. This thing is so cluttered when you have so many of these reference objects. At least give me the option. Yeah, at least give me the option to make to give these things a different color. Well, it's neither here and there, I suppose. What's that? Oh, okay. Okay, So I reckon I need these two in anyway, so that I can have the rough so I can find the center point here. Yeah, like that. So that is the center. So that is the midpoint of this entire object. I want to post. Oh, right. I need that to avoid that pin. So this is, I'm not, oh my, so I'm not going to use it, but I want to see it. That's not an ambulance. Wow, there's so many ambulance running today. Are people getting heat stroke or something? Not that sound. How are we doing this? So I need to go all the way there. Oh, actually, we might actually need to dance around that one. Alright, first thing first. Grab that. That is the circle to which you can spin around without interfering with that pin. Then I need that one. Like that. Like that. Like that now. With a mole. Oh, no, not that mole. Not that mole either. Okay, let's just do this for now. Yeah, let's do this. So these two should be, these three, you mean, to be coincident, like so. And that guy should stick with that. Oh, well, this guy first, and let's just give it a little shampoo here. Or fill it, I mean. What's the size of this? I am using an M3 bolt as the pin to everything in. So I need a hole. Of 2.9. Let's make it 3. Oh, what's it? Oh, it's dropped. Yeah, it's printing. Okay, let's hope it doesn't get out of bed because I'm too lazy to go and check. So the wall around that pin need to be at least 2 mils. So 3 plus 2 is 5 plus 2 again is 7. Plus 2 twice because I need the radius. Plus 2 is a radius. Plus, in fact, you need to double that to make it a diameter. So make this dimension. Make it. Oh no. Dimension. So make that 7. 7 is huge. 7 is huge. Do we want the 3M3 to do this? Seems like a waste. Yeah, 7 is huge. So let's make these two equal now. First. Oh, and got enough coincide. Oh no. Did I already done that? I feel like I've already done that. Coincide. Yeah, why is this? Oh, right, because of this. Oh, yeah, because of this one here. Okay, let me put down here as well. So make that, and no, I'm making these 2 points symmetrical over that line. So, but S there, and things are broken. And it needs one of these. No. Oh yeah, because of that. God damn it. And I make these 2 points symmetrical. Yeah. Yeah, because I coincide the center of 3 circles, and that usually have a lot of string attached, and one of the string is breaking it right now. I don't know how exactly it's breaking. Okay, I reckon the other one is better. And then I'll delete the over constraint later. Yeah. Over constraint? What is over constraint? No, it's not. Yeah, there we go. What's, oh, okay. Alright, let me just give this a dimension now. Yeah, I like to use that. What's the distance between that one and that one? Okay, never mind. I'm not. Oh, yeah, that's not overthinking this. Yeah, it's stupid a number. It's going to get caught anyway. Yeah, that's good. As long as this is passed through the center, I think we're good. So I'm just gonna grab that, give it a dimension as well. Don't want to constrain too many things. So make it 10. The top bit is 7 and the down bit is 10. Look good now. Okay. Now I said not gonna use this, but I think I will now because I want to actually know. Yeah, that is the line of action for the force from the spring. Uh, 10 mil. I want a 10 mil. One sec. That's actually 12 mil. It's very short. I make it 20. It's very short, so I make it 20. It's still about the tip of his finger. Still with 20. Right? Yeah. Now this is the perfect would have been a perfect point to swoop to get some of the item, but not item. What I'm saying. Yeah, just shut up. Let's just shut up and do this first. Oh. Alright, put the hole here for 2.9 so that it is set the M3 to 0.9. Ooh, there we go. Alright, now we need to cut out for this. So, like that. I want to intentionally avoiding the reference line here. Make that and that parallel. That is parallel with this line as well. And now we need to just give it a distance. What's going on? Okay. Alright, that's not. I give that distance instead. What was that distance before? I think before I was 1 point. Oh crap, what was that before? I forgot now. Whatever. Oh. Alright, we can do this really quick. Yeah. Wait, why is this one 1.498? Hello? Something changed in the old sketch? I'm just gonna get this. Just gonna make this 0.2. That's a lot more than I thought. Why is that? Okay. Let's check the old sketch here. Something off. Not no sketch, the old piece. Oh, right. Because I'm. Oh, this 1.4. Okay. That's 1.4. Now this guy should be more than 1.4, right? At minimum more than 1.4. 1.6, okay. Okay. And then okay, alright, I get it now. I get it now. It felt bigger. Tension. No, not tension, wrong side. So that is the distance between these two. And I'm gonna make that 0.1. Yeah, because there's double when you double it up on the other side as well, that means there's a 0.2 gap between that diameter and that diameter. If that makes sense. Hopefully. Now think about that, this shouldn't be 0.6, this shouldn't be 0.5. So that's for the same reason. Now that clearance and that clearance there add up to 1.2 between the two. So they can go into each other tightly, but still go into each other. Upon further refraction, this sharp angle there is not exactly optimal. So I'm going to create a flip. If I can. Hello? Why can I not? Alright, so make those two equal. Oh wow. Yeah. I'm too lazy to just delete that line and make it entirely a curve. So we're gonna keep that like that. Give it a dimension and lock it in. 1.4. 1.4, good. All right. A lot of independent numbers here. So fixing it in the future might be a problem. Up to face. Up to face. Okay. Alright. That should allow me to twist the door side to side with a and lock it in with a spring that attached to the back hole. There, easy. And that knob gonna serve double up as the knob, the little bolt that I'm gonna screw in there, gonna serve as both the attachment point for the spring at the back and the place for me to control it. To know for sure how hard it is to swivel this back and forth, let us go back to the sketch here actually. No, that one. It is in the base. That. Yeah, because I draw everything come off, not that one. God damn it. Okay. Looking cool on myself there. It's that one. Yeah, there we go. So because oh, yeah, no, wait. That's fine. Just keep that around for now. This was set to 10 for. Oh. So we were. So maybe 10. What if we go 20? What would that give you? Alright, this. Alright, that's not good. Yeah. You see the. What is it? This distance here. If you increase the distance here between that circle and that center, the distance to which it has to travel to make a full flip increased to 36, which is not good, because if I grab the movement arm of the servo here really quick, actuator arm. Actuator arm is only 20. Oh no, it's less than that. It's 15 millimeter. It's that. So 20 was a bad call on my end. Yeah. I need to reduce that. So I need to make it 10. So that has come down to 18 now. Oh. Oh wait, no, 15 times 2. Is it? No, it's not. Oh, wow, this is gonna be small. This is gonna be small, huh? So the servo is gonna be now somewhere right there, right? And it's gonna have a movement arm of 15. So this is radius. Somehow dimension. No, not dimension, but mole. 50. Yeah. So if I put it, yeah, so 15 plus 15, so radius times 2 again. So technically I've got 30 millimeter for to move around. So 10 gonna work fine, as you can tell. Like that. So yeah, that hole right there is representing the pin that the servo gonna interact with, and gonna travel in this arc. So if I put the servo somewhere around there, it's gonna work. But I need to make that 10 on the moment arm. Okay. Let me just if someone noticed, everything is working off that point there, so that point is actually very important. And if something go wrong and I changed it, it's gonna be disastrous. Oh, but it's recalculating. Oh, that's going to be 10. It's so scuffed. It feels so scuffed. Alright, whatever. It should work. The calculation said that it's gonna work. I'm gonna have to adjust it for now. Oh, the second thought, I should have. Oh, yeah. Oh, that's good. That's good. I haven't put on the long print yet. I want to print out this lid first, because this is faster to this would be faster to print for one. I might even finish it within the within the screen. Output top. Where is everything else? Hello? There we go. And something's off. Where's my other object? Oh, damn it. Oh my god, that's why. Okay. Okay, I got a little scared there. Trapdoor. Not trapdoor, output top. Oh, that's fine, actually. make sure that the groove section is facing upward. Yeah, like so. Slice that now. Yeah, pretty simple. Slice. Okay, is that two walls between these two? Might not be the smartest thing, but hey, we'll see, we'll see. What's this? 36 minutes. Yeah, just like the other one. It's very fast. Speaking of the other one, how is it doing? You can see it's on the webcam view, eh? It's going fine. I came out of bed. So let's just leave it at that. Okay, so that was 3. Alright, that's it. Have you exported yet? This one. Yeah. I just export it to desktop. Get back to my drawing. Oh wait, what am I doing? We could get the motion arm in there as well. Oh wow, I might have actually may be able to show up the entire motion system today. Yeah, let's see how small this thing is now. Put the motion arm into that print as well. We don't need it. We don't need to have a separate print for that. Alright, slice that. Get rid of it. And close. Ooh, that wall is scuffed. I may come to regret that. I may really come to regret that. Export. What bed is this? Bed 3. Okay, so that. Wait for the other one to be done. Pop this one in. Okay. So trap door underneath it, the door on top of it. Oh, the fan wedge. Yeah, the fan wedge that hold the fan into the base, which is that. The base gonna have to wait until the end of the stream, at which point I'll start it, but and then we can see it tomorrow. And something is wrong. Something is absolutely wrong right now. I can tell you that much. Oh wait, no, I know what's wrong. I know what's wrong because I should have enabled that instead. Yeah. Okay, there we are. Put this, the wedge. No, the wedge I already had a different color. Getting the good random color. Cool. Looking good, looking good. Okay. So we got a trapdoor, the top and the bottom. We'll clean clean off all the sharp edges on all of this later, but for now that's that. And now we need to think about where to place a servo. Where's my servo? It's in the box over there. One sec. Yep. As well. Window. I'm looking for the was it that the dimension of the servo over on Amazon. So why is it huge? That's the right one, right? Oh no, that's not the right one. Oh, it is. Okay. Okay, so I'll grab one of these. I have dimension here, right? What's up? Also, these screws are always scuffed. They can't just. I know I can find it. Oh, there we go. This one. Hmm. 180. I need to know the dimension, the mounting hole, and everything of that. Ah. Come on. I don't want to stand up and grab the thing on literally on across the desk. Give me the number straight up. Come on. SG90G. Oh, there it is. It's not very useful. Alright. I'll grab this servo. I'll grab a servo off the box and read the number of my caliber. I just realized that these servo, the servo SG90 servo doesn't not gonna be easily mounted because the hole on them are, well, the holes on these are not for M3, are not for M3. They are for these little doodad magic there. Do I have those screws? I think I do. It's in the Arduino kit that I have. Oh yeah, there we go. There we go. Alright, these are $2 mil. Oh, so these screws here are cell tapping 2mm screw. Oh, that's good to know. While I'm at it, I'm just gonna put on a one of the servo here. They say not to turn it without anything else, but I'm kind of no way. I'm not. Oh. Okay. This decision of mine will not come back and bite me in the ass. Yeah, it's gonna bite me in the ass if I do this. Okay, never mind. Now I was going to screw in the screw here. One of these are actuator arm onto the servo, but then I realized that might not be the best idea right now because I don't know how they're gonna mount it yet, and these are self-tapping. So if I put them in and then take them out and put it in again, that's third time it get weaker every time. So let's stop myself there. Oh my god. I was stuck for a second. So, just gonna put them away. Cool. Alright, so let's revisit the sketch really quick. Let's revisit the sketch for the pocket there. Not that one. That one. Ooh, so what is the angle? No, because the so we don't need to worry about that. Now 3 mil, let's make it 5. No, don't need to. Yeah, it's not 3 mil, it's 5. It needs to be 5. Yeah, this needs to be 5. Because that is the size of the bolt. And I'm gonna make that and add a tangent so that I. Oh no, do I need a tangent? Yeah, no, I got a tangent here. Why are you doing this? Alright, build that. Okay. Okay, so now, what's the distance here? 18.415. That doesn't have to be exact for what I do. So we got that. That's good to know. Do we want to mount the server down here or over here? Oh, and something stopped. Okay. We can. Oh no. We cannot mount the tank. Yeah, we can. We can mount the servo here and turn that like that. Yeah. Actually, let's do this. Let's mount the servo down there because that the reason why you I don't know. Also, the print is done, so give it a minute. Give it a minute, and I'll put the other one up. What's that? Oh, my phone just dinged. Why would I want to put it there over there? Oh yeah, if we put it there, there's a chance that things gonna may get dicey when the that pin got over there, right? So you want to put it back here so that it avoid anything in the middle, because the servo had a little hub in the middle. Just gonna take it out. Yep, yep. Oh. This one. 15. Okay. I'm gonna draw the. This is the hub in the middle that which you shouldn't. So 115. 1 sec. Let's do the math here. 15 minus 1. So the radius of this is 5. Oh, dimension. Mode. 5. So that is where there's a hub in the middle, near the base of the servo, so you cannot go all the way. Oh my god, you shouldn't press any button like that. Okay, I'll go back to the top here. Oh nice, it's done. Yeah, the print is very what is it called? It's I want to wait to the bed to cool down a bit because the print lay flat, so if I flex the bed now it may bend the piece. So that is the keep out zone for the servo. Oh yeah, you can see it. Right, if I place the servo on this opposite side, there's a very large chance that the clearance of the bolt, the little actuator on the swing arm, gonna hit the clear out zone here. So there's no other choice. We have to put it over here so that it doesn't do that. Okay. Make my life a lot easier. It does mean that sometimes the swing arm is gonna pop up on the other side though. But it's not big of a deal. It's just more of an aesthetic thing, isn't it? That one. So let's do that. The servo needs to be they need to make a servo mount over here somewhere, but not on this piece. Then we have a third piece that bolt to everything for the servo to be mounted. Oh god, do I make the servo a model? I need to make a model of servo, don't I? There's no way that there is one already available online. SG90 model printable. SG90 servo. There we go. I knew. There's no way. There's no way there's not a already one, huh? See? Okay. An arm. You say? Oh, they even have a little. Oh my god. This person is so thoughtful. I'm gonna download everything. I think the drawings here is probably the best thing they give us for this model. So I need to grab that, make sure that I save it somewhere because that is very important. That is very useful. Model. Oh. Straight here. Cut that. Put it down. SG with arm 4. What am I looking at? SG90, SG90 arm, SG90 arm. The hell? What did I say? Oh, That's SG9. That's an SG90, SG90 arm, and an SG90 arm. Very scripted. Okay, I guess he was not whoever. All right, there we go. Oh, that is oriented correctly too, so I don't need to be too worried about everything. Okay. All right. Close that. So man, I think the print is done. I'm gonna grab it. I'm gonna disappear out of the face of. You guys gonna make. Alright, I'm turning on the gain on the mic here, just so that you can hear me out over the at the printer. Hopefully it's not too loud. Oh, I can see myself big a little there. But not as much as I was at the beginning of the stream. So I think because of the noise outside dying down, because the noise outside is dying down and the rush hour is passing, the mic does not have to work as hard. Oh fuck. No curse on stream, but it's goddamn hot. Ooh, and no. Alright. Yeah. Nope. Nope, good thing I checked. But the answer is no. Ah. Alright. I knew it was too easy. So you see here the little pin, little protrusion for the pin here, completely failed to print correctly. It's not round at all. It's showing. Yeah, that's not good. That's not good. That's not gonna hold on to anything. And the hole for the M3 bolt does not look too good either. So yeah, this whole piece needs rethinking. Unfortunately. Alright, let's check on the other thing and while we rethinking this piece. Oh, I knew something was gonna go wrong when knew it. It was going so well, too damn well. Put this away. Put this away. Yeah. Yeah. All right. So what happened there? Now what happened is, let me just remove. Oh, wait, why is this thing here? Oh yeah, because of the clearance circle for the server. I'm just gonna leave it here. Yeah. I don't know. Let's do it like that. That's fine. Oh, wrong button. I just closed FreeCAD. No. Oh no. Don't. Okay, that's good. Oh my god, I thought I forgot to save. But no, it's fine. FreeCAD is smart. It let me oh, this is in the reference folder. There. Oh. That window was bugging out a little bit, so I had to refresh it. Whatever. We can do this. We done this. Alright. So let's get back to what we was trying to say. Let's hide all the things, including the server, because we're not getting that. You see this little curve at the bottom? When you're trying to print it, the first layer came out as literally 2 lines. No, three lines is basically I laid out 3 lines, only 3 lines for this bottom edge here, which actually we showed it via the slicer. Yeah, I'm gonna go to show you via the slicer. Yeah, you can see there. It's like this 3 line here. So when you do it in ABS uploading, it warp, and because there's this so thin, so little material down here, the top layer warp, it's just gonna pull itself right off the bed. It couldn't hold itself on the bed here. And how do we fix that? I don't goddamn know. And also, this does not came out as circular, so this pin does not came out as circular because of all the warping issue and drooping. But yeah, we are designing this in the wrongest way possible. Oh no, it's that's one of that is, yeah, I can add the skirt, but there's other thing that I need to deal with as well. Actually, I was thinking about mouse here. I can always make it just a mouse here right there, make it a little more thicker. That's fine. But this, no, so the thing that I'm need to deal with as well right now is that fact that what it called, this does not come out as a circle. This wall on the corner there, that it just is also very wonky. So I'm looking around for an M3 bolt that I can reach back up. Yeah, here we are. An M3 by 6 of any sort. This M3 by 6. It's not 5mm though. Let me grab 5. I swear to God, this whole. Oh, there we go. I found it. Found one. Oh, not that one. That one. There we go. Yeah. So just to describe what I'm doing. You see, I'm trying to drive a M3 by 6 into that hole there, and the head of that M3 by 6 is meant to be a piece that is that do the rotating bit. So I'm trying to bypass the fact that 3D printed circle is not exactly circles. By using the M3 and using a bolt as the rotating circle. Alright, I'm not gonna model up the jet for now because I'm with the oh my. So I'm trying to put this M3 into that hole there. See if that works. Okay. Alright, sort of work. It sort of work. I was worrying for nothing. Don't worry. Oh, it split the plastic a bit at the end. Is that too much of a problem? Not really, but aesthetically it's not great. Yeah, so you can see there, it split the plastic. It still works absolutely fine as a functional piece. Once again, this bit, yeah, you can put a mouse here on there, but it's not as, it doesn't look good. I might want to try and find a way to replace this whole extension with a metal bit. Or maybe we can increase the size of this thickness here. So this right now is 5 mil wide. Maybe I make it 7, add a millimeter on each side so that the material have more, it's for there to be more material to hold up on the wall around here. Yeah. Alright, we got off. Alright, let's do that. Let's start with adding more material around that hole there. Also, that's not supposed to be where's the FreeCAD window? I don't have a FreeCAD window. Alright. And unfortunately, this is where the this is at the point where we're gonna see if my referencing gonna turn back and bite me in the butt, because if I change the one on the base, will that propagate across every other sketch? No, the body I mean, not sketches. Yeah, because everything is related one way or another. Not that. Not that. Ooh. So I can hide. Is that one the one? Oh, yeah, no, that's there. So I need to hide that sketch so that I can don't go back there. Alright, let's increase this to 7 now. Oh, good thing I make sure to define this distance rather than the distance between the center and that, so that now that stay. That's good to know. And give it a moment. Let's see if it's going to do anything. Yep. So the hole, yeah, the hole is definitely widened, but the trapdoor is not updated, which is good. That mean it won't break. Oh no, it did break. Never mind. All right. I'll get rid of that trapdoor. Wedge or stack? The stacking is fine. Don't need that. Output top. Yeah, the output top broke too, right? The output top is broken, so let's fix that. No, it's not broken. I think it was a base sketch that, and I put that on. Yeah, that's good. That hole is set. That hole should not have been that much wider than the this gap shouldn't be that wide, so I think there's something amiss at the base still. So before I go further and fix the thing that is broken below it, I need to go back here and see, is there like another pocket that I need to worry about? No, that's the one that we just cut out, right? Yeah, okay. Alright, something something broke. Something's broke. I just gotta get rid of that. Something broke. So bad, I just keep that up. That's the one on the side, that's fine. Pad. What's pad? What's this pad? What are you? Alright, that's for the little wedge for the fan, that's fine. Get it off, don't need that. A pad there, something else. Okay, I'm just running this now. Oh, that's patches. Oh yeah, I see it. That's the one that I need to fix. That is the one. Is that the one? Hello? What am I doing? Why are you... Where did this one... Okay, I need to get rid of... Get rid of that. Get rid of that. Don't need that. Why? Yeah, I'm trying to... Why are you... No. It's supposed to be touching that and it's not. Wait, what's this feature? Okay, what is this equal to? What's this? What is this? Between the one. Oh my god, it's jumping. Something here is getting caught. Oh, okay. So yeah, I think what happened is that one of these lines is no longer meant where it's supposed to be, and it just freaked out. Okay, so that one's fine, I think. That one? I don't know what that line is. Or should I say, I don't know what that line is, I just... yeah, I think not where it's supposed to be. And this, what's this? Oh, I need to fix that one first, don't I? Okay, one sec, go. Damn. I just broke something. I just broke something doing that. Vertical that up. I don't know why is this art there? Well, no, why is that art there? What does that art represent? Why does it matter? Yeah, I don't need that, and I don't need that. What I want is that. It's these two for one. I'll go find it. I'll go find what that is in a bit. But for now, I need you to collide with that. And you too. So. Oh. I can make these two horizontal. So that one is fully defined. I need to find that extrusion, that pad there, second pad there. Where is that pad? That pad? Is that the pad? Yeah, that is the pad. Okay. Alright, there we go. I think. Yeah. Same problem. I don't know. No. Yeah. It's not good at, this is not good at what's called. Yeah, this system is not good at keeping which size of the what line is. Make it 0.2. I'm not in the mood to be not generous, so make it 0.3. If it's too tight, we can always increase it. Yeah, so what happened is that that drawing was not able to jump over the pad. It it's still correct. There are two correct positions when you define that distance. So when we increase that circle, the software just couldn't figure out which one is the right one. So the simplest way is to just keep the sketch where it is and trying to get that well, my god, my explanation is just way up right now. It's not working. So when I increase that size, the size of that circle, that's, oh my. And when I increase the size of this circle here, the system will try to recalculate everything, right? And among the thing that it trying to recalculate is just the size of that art there. And the problem with doing that is it does not know, because these two are linked to each other by a distance of 0.3. There are two ways that the distance between these two can be. There's two ways that where this 0.3 can be. It's 0.3 where this thing is smaller than that one. That art is where that art is smaller than that art, or 0.3 in the sense that art is bigger than that art. The system is not very good at figuring that out, so it gave me the wrong number there. So the art was smaller than it's supposed to be. Obviously, I flip it back, but good, I think to keep in mind, because now this might gonna be it had been an ongoing problem so far. I could fix it with equation and all that, but not exactly keen to do so, purely because I'm not very it's a lot of work but not a lot to return, so I'm just gonna not bother doing that just yet. But that is a solution if I needed to do that. Anyway, let's get everything else back on out. Output panel. Yeah, this output panel on the other hand is pretty easily defined. It. Oh, I need to get that hole to meet that curve. Oh my, one sec. Or do I? Do I want that hole to meet? Oh yeah, I do. I was thinking that I'm trying to be smart and have the support structure around the pin so that, it's gonna hug it. But then I realized that's not a good idea either. Mouse here is better. The mouse here is better. So I will grab that hole right there. Yeah. And I'm just, instead of giving a specific dimension like this, I'm just gonna make it equal to that. And by that I mean make these two, that point and that point, coincide like so. From that way, there's a hole. What size of the? All right, that's that, and that is the base. Figure it out, and let's see if it broke anything else here. Oh, it seemed like it fixed itself, right? Yeah. Which is good. Which is really good. Nice. That's work for me. Let's see, the trapdoor is figured out. No, this is a good thing. This is a good thing because I think the base sketch is just, the base sketch I didn't give it I didn't trust the whole desizing thingy, and I still don't, so I'm not gonna give it a straight 7. I'm gonna give it 6.8, 6.7. Yeah, the diameter, I mean 6.7. Oh wow, that's close. It sounded like an accident just about to happen, and then it came out. Whoever drove in the car just now. Yeah, and I want a mouse here right there to support this thing. So actually, let's just do that now. And if this was what? If I like that. No. So hide everything else actually, so that I can see what I'm doing. And I will make that a random plane. Okay. And then I'm gonna draw on it. Yep, I'm gonna draw on it. like that, because I hate the yellow planing. And I'm just gonna draw a circle here. Doesn't have to be, oh my. Draw a circle. Like so, put it there. That's honestly, it doesn't need to do literally, it doesn't have to be accurate at all, so I'm just gonna lock that in. What's the lock button? I don't know what is a KB. I'm not doing that. Some of this shortcut is just weird. I'm not doing that. Alright. And I'm gonna extrude it for 0.4, 0.2. Why is it not showing? Reverse. Alright. 0.2. So give it one layer. Like that. That should hold everything in place. Hopefully. Hopefully. That holds itself in place. Little mouse here. But of course, to save my own sanity there, I will not show this when. Oh yeah, and that also messed with the motion arm down below because that. Okay, great. Yeah, time we live in. Okay. Yeah, I was saying, I will hide that feature like so, showing the feature before that so that I can work on what I have here. But what it broke the motion arm below for good reason, because now I have the giant block on top that was not accounted for in the motion arm. So I know, and also the motion arm is a lot bigger. Okay. That's right. Yeah. This is why I hate designing for so, and I hide the thing on top so that it doesn't hopping in and out like too much. Okay, now I need to go back in the drawing because everything is broken. Oh, god damn it. Alright, yeah, this cannot stay as 10. It's give it 15? 17.5. 17.5. Why is 10 and 17.5 having such a large difference? Hello? 15? What was that? Wait. I think I got this wrong. Go back. Go back to the sketch on the base really quick. See, what did I do? Right. So the so it's the distance was between that the center of the wedge and the pin. So not the center of whatever point that it was down here. So yep, good thing I checked, because now I can get rid of this number. Oh no, I don't want to get rid of this. I just made it with a reference like that. Alright, that makes more sense now. Yeah. Alright, so that is 10. Which is good. Actually look like a reasonable now. More sense. A lot more sense. I do need to get rid of that number because as you can see down here, it's not reaching the bottom. And I'm not sure it's reasonable to demand it up to be. But for now, let's just increase the number really quick. Just how far can I? And it does need to be enough. Okay, let's get rid of that. Actually, just adjust the number myself manually, like so. Now give it a dimension. Radius. No, I like to use diameter. So 13. 13 is fine. 13, 14. Make it 14, yeah. And good. This go like so. One. Alright. Actually, let's actually use this point and do something with it. So make that attention to that. Yeah, and make this slightly bigger than 3 mil. So I want that to be 3.2. 3.3 is good. 3.3 is good. Yeah. And do I want that to be equal to that? Let's think this through. Yeah, actually, we do. Make these two tension. And get rid of that. I don't need that. And that one equal. So basically, it's just wrap around like so. And because I already put a, I'm also already putting some, what is it? Tolerant here with the 0.3. I don't need to be too concerned about the diameter of this. And I don't need to be concerned about things physically interfere with each other. Maybe 0.2 because it looks better. But that's about it. That's good. We can reduce the size of this now because it looks a little weird, a little too big with this. So I reckon I'm just gonna turn this inward like so. Oh my! What is that? What's going on? Okay, like that and that. Tension. Yep. And of course, as always, that's gonna break something, but that's good. Break away. That tension as well. Okay. Also. Oh my, why are you flipping around? Wait, why are you? Yeah, seriously, why are you doing that? What's going on? So what's this then? Alright, I see. I know what that is. Why is it doing that? Why is it doing that? That dimension is 7. Can I not? Okay, let's just break that. Let's just get rid of that. I don't need it to do that. Make these two parallel and equal. Oh, and that one need to be a tension. Why did it broke before? I don't know. Oh yeah, actually I do know. These two now can collide, coincide. No, they two can join up, I mean. And now, alright, that's good. So I will make this now parallel to that. Aha. It looked like a penis. I mean, the ball is a little small, but it's getting there. But let's not focus on that for now. And took a look at what happened here. What the hell am I looking at? Why are you doing that? Well, first of all, it's not fully constrained yet, so let's just figure out where the heck that is. Why is not constrained? Oh, there we go. Is it? No, that one's fine. That one fine. That one fine. What is it that is not constrained? This thing? I don't get it. Where the heck? Oh, what's this? What's this one? Is this the... Oh, I get it now. Oh, yeah. That point was the... because this curve here was created by a Philip tool. So they create a point where these two joined up. But obviously we don't need that anymore, man. We're making these parallel. That's actually not needed. And what's up here? Why is it? Oh, no, it's fine, it's fine. I thought it was sure that something on red there. But otherwise everything seemed fine. And of course this padding tool. Oh yeah, that tool broke. Up to this. I'm actually pretty surprised that's even done. That's actually still didn't break that much, huh? Yeah, because we add this entire piece here, and somehow it still pick up the surface that it meant to be extrude from. And all the feature within the little face that I select just now is still intact too. So I am genuinely very surprised. how well stable FreeCAD is right now. Right, what could it do? But that's enough lowering over this. Obviously the thing on the bed right now is not this, but it's still gonna serve a good test. Alright, so put these away so that I can see what I'm looking at. And put the door back in. Yeah, like so. Yeah, this is where the bolt mounted, one there, and there's just gonna be a rubber band between them. And as you may all know, there could be a spring. It could be a spring. I definitely make it so that you can put a spring there. We need to give some room for this thing to swing even bigger. Yeah, you see, I get some room here for the door to not, you know, completely slam into place. But because I do that, I need to give it some room, more room here maybe. Either that or I reduce the amount of room that I'm giving the door here in terms of the Voron. Now, you know what? Actually, let's just print this out, see how that goes. Then we'll figure the rest out. Right now, that part is overthinking because he. Toggle. Alright, anything I need to do here? Actually, let me just really quick, because one of the thing with the with this was it prototype I'm doing right now, this door here, is that that circular pin profile is not very suitable for 3D printing, especially in the orientation that it is. So I'm thinking if we can get away with a hexagon, or basically just chop this curve a bit here off and just have a straight line, at least on the this pin. If we can get away with a hexagon shape, it will be great. No, don't open it, guys. Don't open it. I need to print it out, see how that goes first, then we'll make the decision. Yeah. Speaking of which, I need to save this, make sure that I don't lost it again. Alright, so that's that. So that's all the pieces. So I need to know, now I need a new mount, something to screw onto this back here, which means I need to punch some hole here in a bit to screw another assembly on top of it to mount the servo motor. And the servo motor is this in here. Where it gone? Yeah, it sits in here. And of course, it's so nice that they have made it. Oh wait, they made it. It's great. It's so great. Right, so the servo will go somewhere at the back here, and it's gonna turn this thing. Okay. How am I doing that? step one. I need to put the servo motor in the right position with assembly. So, but to do that, first and foremost, I also want to do is on top. Alright, I am grabbing that. Put 2 holes on the side here. It doesn't need to, yeah, because it's gonna screw down from the top. It's gonna get screwed down from the top. So, I just need to make it 2.9 dimension equal first. Say 2.9. Yeah, like that. Horizontal it. And move it in. Make it symmetrical. Trying to make it symmetrical. That's it. Where is the whatever? And show that. Oh my, what's happened there? Alright, because you and oh yeah, I don't need this one if I have that one. Okay, so these two should be equal. Equal that. Make them equal. Make that dimension 52. 52. Oh, why are you not no longer touching that? Go inside, please. And I'm gonna keep you over here. Yeah, that looks about right. Myself, make it back. Let's fine. Let's make it 6 because I like round number. Close that, and is this gonna break anything? No. Perfect. Nice. So I don't need to fix anything. The less I need to fix, the better. Wait, that's the print going. I didn't check at all. It's going well. I think it's going well. I think it's going too thick actually. I think this plate is too thick. So if anything, I might reduce the height of it a little bit. That wouldn't change anything, wouldn't it? Yeah, it wouldn't change anything. Alright. So we want to import that and that into a new body. Oh, no. We don't want to import that and that. I want to make an assembly. Oh, the print's done. That was quick. If that was 6 minutes and it's set, and it was a very short 35 minutes. Okay, 1 second. I need to comment on the stream really quick. Alright. Oh boy, that little lash at the beginning is so small. Okay, okay. Ugh. Oh boy, that was a good idea to make it. Ouch. Ouch. So goddamn hot. Ouch. Easy. Ow. Whoa. Are you out? Woo. I don't have the industry finger yet. Chef finger. Cool. Okay. There we are. All right. Oh wait, no, I need to show off what I'm doing. Live stream. Here we go. Okay. So this is supposed to go through it this like so. The oh, this might just work. I just need to go this way. So yeah, the size is a lot smaller than I thought. But ultimately, if the knob had worked, I can use the thing on top here to turn the thing on the bottom. And the 0.2 gap that I gave it actually worked out perfectly. So yeah, so remember when I said literally a second ago when I'm just should reduce the gap on the group here? Yeah, we're not doing that again. We're actually not doing that. It's this actually worked fine. We just need to figure out I just need to test if the mouse is gonna work to keep this pin straight or not. And if that works, that's fine too. That worked out well. And all is right with the world. If anything, the pin. Okay, never mind. No, let's not comment on that too quickly. I was having trouble trying to push this moment arm in. I had trouble pushing this moment arm in place, but the pin is warped to high heaven, so I can't really say for sure if that is a problem or not. But I might want to increase the tolerance there by 0.05 or something to make sure that it does go in. Okay. Ow. Ooh. Okay, I know. I was playing with the servo motor on my desk. Yeah, but this getting work. It is turning out far better than I expected. I was a bit pessimistic a second ago, but now I'm not. Great. Oh, the servo motor. Actually, there's several things need to be changed right now. First and foremost, add some. No. All right, now actually let's do one round of fixing, and then we can make the prototype again. Reprint it all. Moment on really quick. So what I said earlier, put this 0.5, 1.15 instead of. Oh my god. Also, this is remember when I said it picked up the circle? Yeah, it did, but it's still throwing that out as an error. So yeah, let's fix that before it got to the problematic situation. Oh, you don't want to show up anything else. Alright, that's that. Alright. Yeah. Alright. Yeah, because every time you hinge on that little point, you have to do this, so it's not. Oh my. One side. Okay, every that worked. What else was I doing? Yeah, that's fine. Oh yeah, yeah. I was saying that's 10. Yes, but how much is this distance between these two? No, no. That point. Oh, between that point and that point. How much was that distance? 13. Oh, that work. That would still work. That still work fine. Because this should be the center of the servo as well. I was planning to put it up here for a bit, but then I realized put it there would might be the easier path. Okay, okay. Oh, and of course I did not. Oh, all right. So I was toying with the Canon background there, chat. Don't worry. Totally showing off the whole thing on camera just now. All right, all right, all right. Okay, okay, okay. Trapdoor. On the trapdoor. All right, yeah, yeah. Let's trapdoor. Put panel. Let's export all of this. Print them out. Let's see how that goes. These three, I mean. So that is the top panel. Sweet, yeah. Trapdoor. Oh my. That's the trapdoor. That's Control Q. Gonna close the window. Don't do that. Trapdoor. That's the trapdoor. Yes. That's motion on. Motion on. That terminology sounds scuffed. Put this over there. This over there. What the heck did I just do? Alright, just do that really quick. Oh, come on. Oh yeah. Oh yeah. Things are bugging out, boys. Alright, alright. Just trying to make do with what I have right now. Where's it? Get over. Oh, no, don't delete everything. And where's everything? Alright, so get rid of these two. Get rid of that one too. Don't need that. That one is till later. So right now, what we want is where it gone? Where did it go? Oh my god, it's motion on. Yeah, look much better there. Top panel. That's good. And trapdoor. And of course we put the side with some mouse here down, like so. That worked right. Oh shit. Oh no! I was shot as infant. Can you do this area? Yeah, well, I want this thing to go in that orientation specifically because a solid infill to be. Wait, what's this? What's going on? What's going on over here? I think I extrude the mouse here, but in the wrong direction. Did I? It wouldn't have worked if I did that, right? Oh. No, that's fine. What's going on? Alright. Actually, don't check it over here. We check it here. Oh. Oopsie daisy, I think. No, I didn't. The hell is going on? Yeah, no, you can see it here. Oh, hello. Why are you in a weird angle? It should have just touched, right? It should have touched. No, so... Oh, just find it. Yeah. Why is it doing that? Oh wait, no, it's fine, it's fine. Oh yeah, never mind. It does touch there slightly. Something was off. It's off, I think, but I don't think that worth trusting. Yeah, something is off, but I don't think it's worth trusting. So I'm just gonna go back there. Let's just slice this, print it, and see how that goes first. Then we'll second thought, I don't think that mouse is big enough, but okay. Oh, it's like an hour. Ah, one. All right. Okay, so that's that. Shall now load it into the software. Let me clean that up, get it out. It's 01, yeah, so that's that. And it's gonna be an hour and 30 minutes. Really should have reduce some number to get it faster, but I need to see how much no, I need to see how much it's what is it called, the warping gonna be with these pins right here. So I don't want to change any print setting at all. Gonna take a while though, so I'm not sure. Is it gonna finish within this stream? I don't think so. Holy shit, I've already been streaming 3 hours. What the heck is... Where's my time go? I was chilling. I was just chilling and now I'm already running out of time. Do I keep streaming? It's 9 p.m. on a Friday night. Yeah, I got nothing else to do. I'm streaming. Keep on streaming. You know, if I fill it... Oh no, if not fill it, but it's a chamfer that edge. What's gonna happen? I'm curious because there's this. It joined up into this one very dodgy point here, right? So if I try to chamfer that, nothing happened because it broke. Okay, good to know. Cancel. All right. Back to oh, is it running? Hello. 1 second, guys. I need to reset my Windows. So I'm just gonna do this separately. So I got too many windows open. Now if so it's kind of broke sometimes. Let's give it a minute. Alright, that's good. Yeah, that's good. Alright, there we go. Yeah, that's what it's meant to do. Oh, and I noticed the FreeCAD window is correctly positioned. Okay. Alright. Back to FreeCAD. Put that down there. I don't need that. We'll motion on back in. So the begins just all look good. And now we shall. Oh my. Now I shall make an assembly. Where's the assembly tool? Yeah. Create an assembly. Gonna add the trapdoor, top panel, and that motion on. Oh, and the that one too. Yeah. Okay. Does it take it in? Let's see it. Yeah, it does see it. Okay. So we want to base everything around that piece there. So that goes first. That is the output top. The naming there is a little scuff, not gonna lie. And why is it placed in that weird position? Also don't know. Then I'm gonna most up to where's it gone? Trapdoor. Why? Oh, god damn it. Why are these positioned so differently? Which is annoying. Single order. Alright. Come on. Like that. Okay. Oh, why is that affected? At point 2, it is. At that point 2. Wrong direction. Hello. One sec. I need to find it. One sec, chat. Right, it's alright, we go. Make that and that. So that and that. Like so. Oh my. That face and that face parallel. Cool. Cool. Okay, so that is the orientation that we are working it. And why are you poking out far longer than it should? What the heck? Am I crazy? I think I'm crazy. I missed something here, didn't I? Yeah. Stick out a millimeter longer than I should. God damn it. Alright. Get rid of that assembly. Oh my god. Oh my god. Trapdoor. Motion. Yeah, I see I designed it there, but not the distance. Oh, because I need. Alright, this need to go all the way up there. Oopsie. Oopsie. Alright, let's see if this broke anything. Oh, wait, no, cancel. Up to face? Up to face. Yep, cancel. Okay. Select face. Yeah. But of course, make it a negative 22. For some reason, it is the reverse here. Okay. And I need to delete a millimeter off the top. Where's the other pen? Yeah. We should delete a millimeter off this, I see. Yep. Is it not printing? Oh, it's just broken the bed. Is it doing anything? Hello? Yeah, well, there we go. Yeah, look, that look right. That's correct. So, back to the assembly, which now should go all in place. Okay. No, ignore that dish, because that dish does not matter. Or I can actually, don't need to ignore it. I can, in fact, go in there and move it out, like that. Nice. Cool. So now, what do I do? I want to put it there somewhere, right. But these two should be parallel? Yeah, parallel, okay. Cancel. Did I make that parallel joint or not? Oh no, I did. So start printing, give me a sec, I will have a look at it. Okay, like that, so now those two are parallel. And that should be... Oh, why is it switching? Save first. Save. Make sure I save. That and that. Oh, why is it bugging out? Hello. Okay. Alright, there we go. There we go. Okay. So... I think it's safe. We're still safe in terms of... Slow it down. How tall is this? I know I can just grab the model, but I think this is genuinely just faster if I measure it by hand. So I'm grabbing it, a caliber here, and I'm just gonna read out it, and it is 5 mil. That and that need to be a distance of 5 millimeter. Add one more just in case I need it, which is might not be a good idea because I need to know how well that one. Wait. 5 mil. Okay, no. I think it's fine. I think it is fine. 5.5. Yeah, make it 5.5. A full millimeter of extra space might be a little bit too much. So 2.5 is good. Alright. So, alright. Alright, so I need So with all this in place, I need the trapdoor, and so basically I need the top out, not the trapdoor. This is the output top and the motor in one sketch. Okay, so part design, new parts, not in the assembly, no. Yeah, don't put it in the assembly, that's a bad idea. But I do need to grab the items on the part assembly though. That's gonna be interesting. What about that? So the motor, for sure. We want the motion arm? Motion arm? We want motion arm? No, we don't. I'll put top. Yeah. Oh, right, motion arm. Yeah, we do motion arm. Just so that we know what to do with the clearance. Okay. So that's it. Just put those all away. So now we can make the mount for this thing. That's a print point. Let's do the sprint thingy. Oh wait. Totally forgot. This and that. Oh, it's 5 mil. With that, how much is? I'm just gonna do some measurement here really quick. That is 2 mil, so the little extra room here is 3 mil. Yeah. I need some space, basically, for the rubber band. So 3 mil. 3.5. 3 mil. So this gap here is 3 mil. 1 mil for the rubber band. 1.5 mil for the rubber band. Yeah, actually, I take it back to the assembly really quick. I would say I take that back. What I just said earlier about the 6 mil being too much. 6 mil may be it. Okay, I could not see what's going on. It might have changed, but it might have not. So let's test that out before we continue. Oh, it didn't work. God damn it. Reset. Oh wait, no, don't get rid of it just yet. Are you gonna redraw yourself? Hello? It's not working! God damn it. That's why we do that again. Oh. I used the wrong one, I think. No, I didn't. Okay, never mind. No, I didn't. Is this one still? Cancel. Okay, no, I did the right one. Alright, so within assembly, did it work? Alright, so it selected 6. Yeah, that's assembly itself worked fine. So I just need to do that again, I suppose. Damn it. Alright. I don't know why I did that, but here we are. This is servo mount. Or this would be either the servo mount or okay, never mind. I was just this close to say I'm just gonna make the entire top piece that funnel the air, that's both the servo mount and the funnel bit for the air to come down to these two fans. But then I realized this assembly is scuffed, so I don't want to do that. I just want to make a little servo mount that I mount to the top piece later. What's gonna be designed later, which is another thing that I need to design and then print and test. Oh my god, so many things to do. All right. All right. Put that away. Don't need that. So how are we doing this? Could we just extrude something here and then extend it out there? I think that's that, right? That's not that hard. And oh god, I know we're bumping between a couple of only a couple of concurrent view at a time, but we had collected at least 110 viewers view, which is a substantial number. I'm happy with that for the stream. I mean, this is quite a boring stream, so whatever. Let's not think too hard about these things. All right. Where am I going? Where am I going with this? I want that face. Yep. Yeah, I'm just gonna draw that out there. No, would that face be the good face to have it? No, it's not. All right, I take that back. I got rid of that face. No, actually, the key determining factor is how thick the wall on this thing is. It's a 5mm wall, right? I can't remember correctly. So that one and that one is a not shown up. Okay. 3.6. Oh, the wall is only 3.6. Well, that's very hard. Why did I do that? Whatever. We I still feel a bit of puzzle. Why is all the when I pull the body into the assembly, it's just floating there instead of where it's supposed to be, where it was designed it. They don't used to do that, so that's very strange. Anyway, this wall is 3.6. And you still need to reduce that length. Oh my god, so much work. Ow. My hand hurts. Alright, that wall. That created the thing in there. And push it in by 3.6. No wait. 3, 4. 4. 3. Oh. Okay. That sounds good. Alright, so we need to cut some room into the wall for this thing. How are we doing that? Cancel. Alright, I take it back. I'll stop. I stop at this point. We built the mount first, and then we built everything else around the mount. At a time, trying to account for everything else for the first. Okay, put that away. Now we shall take. Join that. Why do you put a chamber here? It's so annoying. Well, it doesn't matter too much, but you know, it makes life so much harder to play. There we go. Let's grab the whole face. Okay. Do we cut them out now or later? Later. We cut them out later. Yeah, oh my god, why? Those things just love to snap the center point, don't they? Vertical. These two to be equal to each other. And dimension wise, they should be 2 mil. 2 mil. 2 mil is good. Yeah, and then that is so. Yeah. Honestly, this doesn't need to do anything, and this does not need to be specific to any length or dimension at all. So I'm just going to I'm just gonna guesstimate it what to do with this. Okay, that dimension 60. Yeah, 60 seems good. Who needs some perfect symmetry? Am I right? And what's it doing? I can hear it. Okay, make it flat. Great, yeah. Okay, close that. Extrude it. Oh my. Okay. Right, that base. Okay, so actually, let's make a little. No. Alright, choco size. I do want them to be horizontal for one. Make them equal. Get rid of that. I want those holes to be in view. So. Okay, because vertical. Yeah. Why not working? Hello? There we go. 6. Oh, yeah, I can't help it. I need symmetry and actual good numbers. Close that. Okay, now we can extrude it the other way. Reverse. Just cover up the hole. This one on the other hand, let's just do that. Okay, no, not too far. That's good enough. That's good enough. I just thought of some way to make this easy to print, but I'll do that later. Okay. So for now, let's make it transparent. Yeah, so that I can see the thing inside of it. So I need to cut out this groove for one, and I need to cut out the groove for this piece and the piece on top of it. So this is truly the time for me to go back to the website really quick. So I need to grab the size of the servo arm. I'm not going to show you guys this because it's rather obtuse to do. Okay, I said that I don't even have it. Oh, there it is. No, it's not. Okay, god damn it. Now that was a servo arm on the SG090. XG90. I just assume that we know. Good. Price. What price is about? Oh, got it. And no, I'm just gonna hide that. Gonna put this over here. And that's what I'm gonna show you now. One. Yeah, that one. You need to know the size of that thing there. Okay, then it. Oh my god. Ah! I swear to god, let me try. Oh, there you go. 34.5 millimeter. Okay, that's easy. Just make it 35. Okay. So we need to make a 35 hole around the. Like that now. I want to cut a 35 mil hole starting from that face there. So let's just make a face there. Draw a little thingy. Cut it away. Give a center. Give me a center there. Okay. Grab me a circle like so. Make that 35. Just cut that. Oh my god, not 345. That's a bad idea. Oh, there's 5 concurrent viewers here, so if you guys can like and subscribe. I don't think many people are new here that's not subscribed, but if you can give the stream a like, it will be a great help. Thank you. Oh wait, hello. Look at that. That covered the bottom bit too, so I can just cut it all the way through and I will be in Gucci mode. Nice. Oh, reverse true. Yeah, so that's it. No, that made things so much easier. And because the circles, the radius is so large, I don't need to worry about these angle here of this curve to be bad for printing. So now what the only thing left to do is for me to drill out the hole for the mounting, and we are Gucci. Perfect. All right. Save it. Making what you see. Alright, put the surface on that. And draw on it. Hide it, because I hate this yellow. And hide this too, so that I can grab me holes. There's the back hole, the front holes. Then drew some holes on top of that. This hole here are, what is it? 3.4 mil? Oh no. We make that equal first, and then we make this one dimension 3.4. Huh? What's this thing? Oh, it's just goes there, punch through. Okay. And now we need to drill the hole for the self-tapping M2 screw up here. So oh wait, I need to drill out the hole. Oh god, I thought I was done. Alright, never mind. Yes, I need to make the those 2 holes for sure, yeah, but I also need to cut out the hole for this section here. So it's not done yet. Can I get away with it? Just cutting it out? No, I cannot. Okay, never mind. Oh wait, what the heck? I got confused by where my imaginally. Got that. I did. Drawn it though. Put the holes in there. These two. Alright. Let's hope we don't find out later on that the so 2 mil. So in term of like in term of the 2 mil is the screw. So I reckon I can make that 1.8. Yeah, making 0.9 dimension 1.9. Yeah. I can always make some mouse here, but this is like very small screw, so I reckon just make the screw hole is fine. How deep though? How deep though? Let me grab the screw that I have here really quick. Just see that I let one go. Yep. This is 5.3, so drill down by 6 then, to give it an extra millimeter for clearance. It's so nice to have the hardware on your hand. You can just measure it with a caliper. Right, drill down by 6 mil, like that. And that's so good. Alright. Now we need to cut out that bit for that and bit for that. You can see that so just hide the working bar body real quick. We see this little tip here. That means the what the heck was that guy? What's going on there? Okay, so we create a face surface there, so we can drill up and we can drill down on that same surface. Okay. Like so. We want the center of that. Okay. Can we just not add a giant hole here like that and call it a day? I might be, actually. Let's try that. So extrude it the other way, reverse, all the way through. Yeah. We can just cut out the what? We may just get away, naturally just get away with a square instead of a circle, actually. Yeah? No, rectangle. Yeah, rectangle. Yeah, let's go for a rectangle. Oh, don't. Not. A centered rectangle. Like that. Oh. Okay, maybe not. Maybe not a center rectangle. Normal rectangle. So. Yeah. Just make it bigger. Do we need to be exact? No. So let's just plug it in by this thingy here. And call. Oh my god, today. Almost click the wrong button there, but that's also good. Can cut through. Punch it the other way through. Cool. Okay. Like that. Draw on that face again. And for the same reason, oh, actually, we do need to. I want that edge there, so I can line it up with this one as well. But otherwise, I'm just gonna grab that. Make it big. Bring that combo down as well. It look good. Otherwise, just lock that one in. And we can just punish roof the other way. Cool. Okay. And that's it. We got the mount for the servo. Nice. What time is it? It's nearly 10 o'clock in 20 to 10, yeah, here in the UK. I mean, that means we still have time, that is, right? So, anyway, that's that. This is not needed, but I want to do this. I want to trim this corner there, so that we're not. Actually, there's no good reason to do that. I just want to do it. No. Okay. Now. Okay, hide that dent on the plane. Look like ass. Okay, now we grab that, and then that. Trim it down. Okay, actually, to give some order to the madness, I shall grab that line and that line. Once again, oh my, there's no reason to do this at all. I'm just doing it because I felt like doing it. And that is, I want to trim this to, we're gone. Hello? That one? Wait, don't get rid of that. That shouldn't be that. Oh, actually, that's just vertical. Wait, that vertical. And that vertical. That one, can I go inside with that? And that one horizontal. That should. Why is that look a little off? Hello? Yeah, a little off. I don't know if that's what's up. It's alright. It's alright. Close that. And now we punch it through. Or I make a mistake somewhere. Oh, right. That's not that point, not that point. Ah, shoot. Alright, there we go. That's what I'm going to cut. Yeah, so that there's that T2 surface here. No good reason, just 1, 2 there, but that's there. So that should be our servo motor. Yay! Oh wow. Just trying to think now, what can go wrong with this? What could possibly go wrong? Right. Oh, that's good enough. Fine. just hide these now. Alright, so that's the mount for... I still find it a little bit annoying that I have now this floating body for the thingy. How do we care about that? It is servo mount, but yeah, just name it first and figure out the thing over thinking. Servo mount. Servo mount. Why is it not? Make that an M, capital N, and an S. Yeah, that's good. I do not like screw it, we'll figure it out later. Just put it no, because what causing me to a bit of concern here is how am I gonna cover this up with the piece that going to be going over on top of this. And ultimately, as you say, then you know what, let's not bother with that. Let's just make it the easiest way we can and move on. And the easiest way we can is just not cover up the back here, just face. It made no sense if when I am doing it at this point, so you guys have to trust me. It is where it is, and we're not gonna touch that part anymore. Just pretty straightforward and mount these two holes here. Alright, but with that I can put the base back on. Oh damn, things going fast on here. So now the next thing to do is the funnel. The funnel that is part of the base, but because of this trapdoor here that I cannot make it all in one piece. Oh wait, no, this trapdoor and this screwed here that because of those two that I cannot just do it all in one go. Is that true? It's not, but too late to change now. Is it? Think this through before you go too far. You can in fact just put a screw up from that side and not worrying about this being low enough, right? Right. But then you still need to deal with this bridging. This whole piece should be print on its own and slot in place, rather than being part of the whole base, because that's really hard to print this bridge on its without that. Speaking of which, yeah, I'm have second thought on this hold here. So once again, the reason why this base is the height that it is because I need the clearance to put to then shove an M3 by something bolt through this hole here to hold the fan in place. So the bolt coming from this side through, but now that I look at it again, maybe I can put a threaded insert here or at the back and then just bolt it in from the other side. That is an interesting thought now that I thought of it. But no. Damn. Do I want to try that? I might want to try that. That's actually the better idea than what I had before. I might want to create a different body then for the base. So if I'm gonna do that, if I'm gonna extend the top all the way up and trying to make the base a single piece, I need to extend this top up. I know I to extend this up, this whole to extend this wall up past this fan. If I want to do that, I might want to create a clone of this, so that I don't mess with this current object, because if I do, everything else beneath it, like literally everything else based on that, so I don't want to touch that unless I have to. But I'm trying to think of reason why I may not want to. For example, the installation of the well. Okay, never mind. I have a perfect excuse. Do not extend this base into a single piece with the funnel attached to it, and that is because of this wedge here. You need to find a way to put a wedge into this where it is in the assembly, and you need a top to do so, and some space above it so that you can drop things in. Right? So yeah, you need a funnel. Not this. Not a one single piece base. All right. So that's that. So put this away and hide that as well. Make sure that's hidden because it's hideous. Now I just need a new body. This system is getting far more intricate than I want it to be. What I'm saying, I do like it to be too intricate. It's just that difficult. No, it's just that it's a lot of work. I just getting lazy. One sec, chat. BRB. Alright, everyone, and welcome back to another video. Right, after months of doing the documentations for everything going on in this printer, I hit the top, the notch probe, and what else do I make? We can now finally start on the last piece of this puzzle, and that is Right, here we are. Back. Mm-hmm. Okay. What am I to do? Yes. I was gonna build a funnel. Funnel. Okay, the funnel. What are the challenge with the funnel? The funnel. Oh wait, before I do the funnel, let's correct the depth here first. Yeah. So was that one? No, it's the one that before that. Okay, that one. Yeah. Close that. Wait, what's this step? What is this step? Okay, first time try always fail. Good to know. At 37. 37 minus 6. 31. Oh yeah, so totally fine. It's fine. Alright, so what that means is I can punch whatever hole I want. Dimension. Hello? Oh my god. Alright, I'm just gonna spook. Okay, save it. Save, always save. Dimension 6. Make it 6. How deep is the bolt on a M3? I swear to God, I should remember this by heart now, but I don't. Well, that's about 3 mil. Okay. Alright. No. Yeah, keep it. May not fall. I was gonna. May not fall. 3.5. 3.5. Yeah, to make sure that it's flush, not pulling it out. Okay, there we go. So that we got this long line here for the bolt to compress. That means that we can use the same bolt that we would have used to screw this fan in, and screw that one in, and that one in. Reduce the bolt type. That's good to know. Totally not because I just thought of that just now. Right. Alright, I have been was it stalling enough? Built a funnel. Oh, you said it right? Yep, I think so. And I want to get the funnel in, get the base. I need the base, so I hide the base now. I want just trying to undo that coloring. Now the trouble that I'm running into is what alignment system are we gonna use to keep the base and the funnel all lined up, right? So I'm thinking maybe before we do anything more, we add a little thing here so that we can line a hole in here. 2 hole on this, one there, one there. So basically the screw hole for the base and the funnel to be able to screw to each other. And then we can add one there as well. So 3 in total. Yeah, let's do that. Let's do that before we make the funnel. Oh wow, it might broke everything. It might break everything. Alright, let's step 1. Actually, alright, I am very confident that it's gonna break everything. So what I'm gonna do, I'm gonna make a what do you call a copy of this. What's this version? ATCV3. Yeah, there we go. That one. Copy that. Duplicate it. Make it V4. Oops. So that V3 is gonna stay V3. 0.3, so let's say 0.3. I'm gonna mess with V4 here. And specifically, I'm gonna mess with this thing here. Pretty sure I have that surface selected some point. So that display, no. Is that one? No. That one? Yeah, that one. Alright, so draw on that. I'm just going to add. If we add a little holder thingy thing here, it's not gonna be. Oh wait, no, we can add one there, and one there. 3 points. But because of that, I cannot draw them all at the same time, unfortunately. How big is this? 6 dimension? 7? No. Give it more meat. Give it more meat. 3 plus 4, 7. Oh, yeah, 3, 4, 7. Okay, never mind. 20 divided by 4 is 5 wall. Yeah, 5 wall. We got plenty. Okay. Alright, make that equal. Yeah, and I make those specifically equal instead of the touching these, because I'm gonna grab that 2 there, flip, make it little curve here, and I'm gonna grab that. That's that to the midpoint, make this vertical, and lock them in. Extrude it. Wrong way. Reverse. They want 10. They want more. We want more. Give it 20. trying to think if there's any hole in my plan here, but I don't think so. So let's just keep going. Oh yeah. Oh yeah, it's already stopped breaking. Wait, why is that broken? Not that anything else. Hello? Oh wait, no, because that's the assembly free. Ah. I don't want to do this. I'm not doing this. Alright. There goes that. Don't save it. Get rid of number 4. Duplicate them 3 again. Okay. That's too loud. Okay. Oh, what I get? Oh my god. Yep, that was too loud. Sorry. I just need the music to be louder to drown out my misery here. I'm gonna rename this as base but reference because I'm not gonna use that object anymore. That object need to be updated, but I cannot update it directly. I need to make a clone of it, so that's gonna be the new base. Okay, because I did that, we lost the reference point, but for these two fans, not a big deal. So let's just keep going. Now let's just close this up. Okay. We grab that same plane there. No, we grab that plane then actually. Yeah, let's grab that one. Okay. Alright. This side, like before, we grab that line. Doing the same thing I did just before. Vertical. Yep. Make that dimension 7. Okay. Then extrude it. Do I just extrude it all the way down to just keep the whole thing easier to work with? To print, I mean. Reverse by 20. If we can touch it, yeah, okay, there we go. Can I do that? I can. Oh, let's just do that actually. Let's just do that. Select up the face. Yeah, because if you have that little ledge there, you need to then make another feature somewhere. Create a feature somewhere to no, not feature. You need to make an angle so that the ledge can be actually printed. And right, if I just extrude it all the way down to this base, that means there's no overhang, and that make it easier to print. We don't know ugly doing this. Alright, I take that back. Make it 20 again. Me and my stupid sense of aesthetic. Draw a triangle. First grab that line, draw a triangle. Dimension that 60. Yes, it's good. So give that one a dimension 2. 15. Don't need to be exact. Leave a second. How do I do this? Should I spin it? I should spin it, no, shouldn't I? Let's just spin it. Revolving cut. Select edge. Select edge. Not face. Select reference. If I can see it. Round that. And to up the face. Reverse. Hello? Why are you not working? It cut the wrong way. Why did it took such a large jump out of it? Hello? Alright, so that's it. Just give it 90 degrees. Yeah, that's good. That's what I want. Now that is make it a lot easier to print. Though I do think I need to make it a little longer now. Because of that. Give it 30, give it 30. Yep. And the group going chain along with it too, so that's good. Alright, that's first mounting point. Now I need to make another one right here. Start drawing that. And likewise, we actually I'm going to use this tool here. 3 point something. Okay. Gonna make this a construction line so that we can ignore it and draw that and move it. Why is it there? Alright, because it got stuck in that center point. Side there, so roughly that there's good, right? Like that and that, look at the tangent. Yeah, that's good. And make that dimension. Oh, no. Dimension. 7. Yeah, 7 again. Part of me want to make this even thicker. The other part just don't want to try. Because I know it doesn't do much. Oh. Yeah, whatever. AG. There we go, like that. Okay. Extrude. Oh, let's see if this is gonna break anything. Up to face. This face is gonna be trippy. Hey, it worked. Yeah, we'll figure out the correct sizing for these pads later. You might just want to. Oh wait, no, we. All right, so now. Oh, no, not that face, not that face. That one. Yeah, that one. And here's the reason why. I make sure to give it a. Oh, not that. This can go. Alright, first one, this can go. That's a wrong sketch. I'll try that for a sec. Well, that. Alright, well, what was that? Yes, I was saying. That the reason why I give these a curve like so, because I want to be able to locate the center point here correctly. It makes it a lot easier when there's a curve somewhere, or you can just use the center of this. And I'm gonna make that hole. That's a hole. That's a hole. This one specifically, I want it the center of this piece, so symmetrical right there. And now we just need to put it, give it a number. 2.9. Yes, I decided against make it this a what's it, threaded insert kind of hole, because first of all, you're not gonna touch it at all after you installed it. The only reason why this is here because you need the room on top to mount the wedge and the top cover here. Once you get everything's in, this is all mechanical. So I don't think you ever need to this is very robust mechanical stuff. So I don't think you ever need to take it out again. So you can get away. I think we can get away with just thread it directly into the plastic with a screw. To say that I say 25, maybe a good number. 20, no 20, yeah, maybe 20. Yeah, the key here is just not to punch through that one, because that one is where the fan connected to. The rest of them are completely fine. Yeah, that one looks sad, so I'm just gonna make it 17 is good. Okay. Alright, now we can hide that, and I think that is the base. Oh wait, no, done. For a second time. Let's see the check on the print. The print is 70 89%. Oh, 80% done. 79%, 80% done. So we should get something out of it soon. TM. Alright, so now that we got the base out in, the funnel can go below that or get it a little bit for now. With a new body because I want it to be below the base. And the funnel. So don't put the base in there as a reference point. So that's gonna hide the base. We might want to put these two as a reference as well, but I don't think so. What I'm trying to do here is grab that. Oh wow, I can just extend it away. No. Let's not take the shortcut. Good. Grab the bottom one, the size one. Alright, what's the fastest way to get this done? Grab that, just throw it out. Oh wait, no. We need that in the middle. Yeah. Do we? Need that bit in the middle? We might want to draw that bit in the middle separately, don't we? Press mode 3 times to get the right mode there. Same here. Like that. Okay. Oh, it all locked. What? What's happened there? Alright, I think this one is horizontal. Now slightly extrude it. Just a bit. Keep it fiber. Yeah, because I want that straight wall here for a bit of straight wall here. Just so that I can screw stuff into place. Talk away forward to make this. No, because the thing here is we don't need this bit in the middle here. No, we don't need this to be this thin. We can go all the way here. One sec, really quick. So what I'll do, we're gonna make a sketch. So like that. So we don't. Let's not do that yet. Alright. So on that face. Oh, what did you just flip me to? Alright. So right that way. What I want is that face. Let's hide this. Go now. Grab that. Grab that face. Triangle. This is just a guided kind of thing. Oh, right. Oh my god. Alright, before I do any of this, I just realized. Oh no, let's just draw it first, and then you can see what I mean. Oh, not where I suppose you go. That go up. Oh, why you keep snapping into a center point? Freak out, you son of a bitch. This dimension needs to be 60, right? And boy is it big. Okay, no, so two things I'm missing at first. Yep, this need to be 60. And second of all, this room here need to fit the servo motor. So how big is the servo? Close that. I need to go to that assembly really quick. Good thing I didn't break it. Yeah. If only. Transform the whole thing? Can I transform the whole thing? Yeah, I can. Exact here. I just need it to be. We're gonna need to build in some clearing anyway, but it's really good to see. Okay, I keep saying that, but then I can do what you see right now, which is weird and idiotic, but I'm doing it. All right, that is almost. Yeah, that's perfect. That is perfect. Okay, and the reason why I show them off now, so now via on, we don't need to. Yeah, like that. So that's what the sketch gonna do. Awesome. Did I mention that? 37, 38. Wait, how tall is this? It's not. Yeah, because there's a couple mil here. So. This is just a reference, but don't be too worried by anything. So let me just dimension there. Give it 3.6. 3.6 right now, but now I need to know what is this height. About 60 mil. Alright, so far, how high am I already gone? Have I already gone? Wait, why is it not showing up? Oh my god. 60, 16 plus how much is how tall is this base over here? Hey, the print's done. 105 plus 60, so 165 so far. Oh, we're already halfway, more than halfway. Hopefully I hope we have enough room for the filter. Otherwise we need to make the otherwise we need to make this funnel thingy and the carbon basket. Double up at the carbon basket. I might just say something really smart there. So let me just calculate on a piece of paper here how much we have left, because I'm aiming for a 250 millimeter total height. So use that, take off 165. We got, I'm not doing the math in my head now, I've been streaming for nearly 5 hours. 65 on the calculator, I got 85 millimeter left. Oh my lord. Alright, I might need to negotiate with my own conscience on how this servo motor should be placed. Maybe I only, rather than trying to extend the funnel all the way to the end there, I may just cut it up right at that point and trying to fit everything else in this volume. But speaking of that volume, I need to check something. The reason why I want to take the reason why I wanted to the reason why I want to have the funnel all the way from edge to edge there is actually because of this distance here. This is 260. The filter that I want, I am eyeing on Amazon right now, is 140 millimeter per piece for 2 pieces, and the idea was that I can stack them next to each other. So private tab, and let's show you via this window here. Oh, one sec, I need to I'm turning on the Amazon tab, so that you can see what I was looking at. Is this the one? Yeah, do pack replacement for baby bottle, whatever that is. And then no, that one. 2-pack. Alright. Oh wait. I get it. Yeah, that's what I'm looking for. Alright, let me minimize that to make this big. This is what I wanted in, and you can see. Let's check the height of this thing really quick. Oh, I know, the height is there. Is it? Alright, no, it's the length. I mean, the length is the length is 145. So 104 by times 2 is 290. Is there a different sorry? If I can find a HEPA filter. HEPA filter that can fit HEPA filter replacement. Filter one. Oh, wait. Let's just say something. I just say something interesting. I can 1 to 60. It goes to 60. Can I have 260 in blend and a skinny one to 60 now? God damn it. Reset. Got these two as well. Why is there? It's not an angle I want. Come on, listen. 67. Okay. 67 by 260. Yeah, I had some other option before, but as I keep changing my mind now thing just doesn't really go match any of the filter that I was looking at before. Filter. HEPA filter replacement. Yeah, let's go replacement now. Yeah, there we go. Replacement, not that one. That's not a HEPA filter. What's this one? Alright, that's 12, 2.8 in width. 2.8 in width. I think that dimension is wrong, isn't it? There's no way. I'm holding a ruler right now. The ruler itself is already 30 mil thick, so 2.8 mil thick is no 2.8 centimeters thick is not reasonable at all. Yeah, it's as skinny as a ruler, and it is as thick as it is wide. So this product dimension here is completely bollocks. That makes more sense. But this means that it is twice as long as we can afford. Maybe we can have a circle one and tap it down. This is what we're looking for, right? 14.5, 7.5. This 7.5 here might be perfect, I would say. Oh, it's 1 centimeter thick. Maybe you can double it up. Yeah. Divided by 2, 2.6 divided by 2, 13, 130. So 140 is definitely too big. I might have just to need to buy it and then see if it trying to fit it, because this is the closest thing we got right now. Alright, what's in my packet? Oh yeah, it's already added to my my Amazon bag. I just need to wait for my payday, then I can buy it. Well, technically, I don't really need it to be No, you know what? The funnel doesn't need to be there immediately after the fan. For one, the funnel does not need to be immediately after the fan. Right? The funnel can be between the carbon layer and the HEPA filter layer. So we just make the carbon layer about that thick, right? We can make the carbon layer as long as we can, excluding this servo motor, and then we can funnel the HEPA filter layer on top to the HEPA filter layer on top of it. And also, one of the thing about this listing here. Wait, that gone. Oh my god, I lost the listing. I'm just gonna grab it here again. Alright, so the one thing that I'm concerning me at this moment is in fact, where's it gone? Oh my god. Why are you so confusing? It's not the same thing. Oh, no, this is. Huh? I'm not crazy. Okay, yeah. This 7.5 here is what I'm worrying about. How far can I switch it down? Because so far, in the middle here, we only got 67 millimeter of space. But the outside of it is 75. Oh my god. I might. If we get a millimeter of wall, can we assume? Oh wait, no, I don't need to assume this. I have a air filter in my room, so I can just try to do this with that. Oh, it's not the same, but if it's the same, if the foam that they use for that filter there is even slightly the same as this filter that I have in my hand, for my little void there, I have at least 3 millimeter of space on each side of the wall before it goes hard stop for the foam to compress. In other words, when I say 7.5, one sec. Alright, I'm back. I just put the filter back to the machine. But yeah, I can squish this 7.5 in 3 millimeter on each side, right? Which should brought me down to a reasonable which should allow me to fit into here, as long as I keep the HEPA filter layer a little thinner on the wall, right? So that's the thought. Only one way to find out, and that way come next week. Oh wait, no, the week after, because I'll this time next week is when I have the funding for it. So I'll figure it out next the week after, so in 2 weeks time. Alright, so we got rid of that, maybe that. So get back to the sketch here. Oh, yes. So I actually don't need this to come on. I just keep the front here because it kind of look kind of cool, right? And it cover up the servo motor in case I will provide me with a way to cover up the servo motor if I need to. Or should I just cover up? Yeah, let's do that. Let's do that. Let's cover this servo motor up. Wait. Don't. Oh, what the heck? What the heck? Oh, good thing we did this, huh? All right, this need to be shorter because it's interfering with the wall. Oopsie daisy. So before we even get to that sketch, we need to go back to the servo motor here until read the first patch of all things. And reduce this by a little bit, make it 5. Alright, like that. And did I disable auto cloning? No. Alright, so here we are. I was trying to use that surface. Oh my god, let's not just get distracted. Alright, then I get distracted and edit that. I want to delete all this. That as well. Oh shoot, okay, that's fine. So why did you do that, Hendo? Make that vertical. Yeah, make that vertical. And draw a square. Alright, so that wall align with this is aligned with that one. Wall line with that one. Don't feel like no. The reason we don't want it to touching for one, but more importantly, because this is how thin this is, we want to give it a specific number so that it doesn't have, so that the slicer doesn't have too much problem trying to figure out how to print this. So 4.4 millimeter nozzle. I reckon 2 is good. 2 millimeters is good. Yeah. Alright, just make these 2 meet up first. One side. Yeah, we'll figure out the rest later. So I'm gonna close that and extrude it. Alright, and cover up the at least cover up the wait out 105 millimeter. So I'm just calculating how much space do we have. Right, the filter is 1 millimeter or 10 millimeter thick, right? If we need, if the worst come to worst, so we have to stagger them. So make it 20. Make it 20. So the height of the carbon layer should be therefore So the carbon layer is 250 minus 105 minus 20, 125. We should reduce that a bit just so that we give some the outer layer a little more room to grow as well, I suppose. Nah, that's alright. It's alright. I'm one a little dangerous today. So 125. Now, but then on second thought, second thought, any second thought I do, but I need to use the bathroom, so I'll be right back, chat. Watch out the printer for. Alright, I'm back. But since we're on the webcam view, I just grab the stuff off the bed while we at it. Okay, let me see what we got here. And the mouse here works at the charm. Really, seriously. Very well, but the problem with the circular, not so circular circle is still here. You see, it looks like a more like a Bayesian than a circular circle. But we can work with that, I think. Yeah, we can work with that. Yeah. It was a right idea to put a bit of extra clearance for this. Nice, there we are. Obviously, just gonna straighten up when you have the second point of reference down the bottom. So far so good. I'm okay with this now. We can move on. Oh yeah, look at that. Yeah, because this top piece is the cover piece is slightly warped, I think. So that's why it's not meeting up with the wall as I wanted to. Trying to figure that out, but it's not a big deal. Not a big deal at all. It's annoying when you have it on your hand and you want to change it. Okay. Yeah, and you remember that point too that we keep giving in the thing? It might relax that idea a little, just a little bit. Oh, I know why. I know why I haven't dropped no trouble now. That's interesting. Yeah, only time will tell how well this is gonna work. And stream is struggling. Oh no, it's not struggling. It's not struggling. Okay. Wanna go on there? Ah, who cares? Let's move on. Wait, we need to do something really quick. Regain my, take my M3 back from the old sampling so I don't lose it. Alright, so second thought, yes. I do have some second thought. Because now that we make this the carbon layer instead of the funnel, it need to be magnetically attached to each other. Which can be a bit of a pain. How are we doing that? How are we doing that? The good news is we already started it. So honestly, we need to redraw the whole funnel anyway. So let's get rid of that. Put the base back on. We don't need it. We don't need this pocket because we're not screwing these two together. Get rid of that. We don't need this pad or groove. Yeah, we don't need any of this. We don't need any of this. Okay. Oh, you can tell that the so I might have overreacted there. Transform that. So because we're in line with. Okay. Alright, so I can put that to back to 6, I think, so that the wall is a little thicker than this. Now, to make it how do I do this? Because when these start sucking, right, the funnel gonna get pulled into it, and we need to seal this gap basically. So that's why I need to make a doorstep thingy on the funnel and on this piece, on this space. No, not funnel, on the carbon end on this space. So that they fall into place, and then we need to add some magnet on the corners to keep them all attracted to each other, right? I'm trying to think of the best way to do so. To me, it sounds like a pain in the ass. Is what I'm thinking. So what if we just extrude a little inward lip in here? I don't want to. No, so what I'm trying to do is I don't want to make this wall any thinner. It's already only 3 mil right now at this point. Don't want to make it any thinner. So let me grab the camera really quick. I think I can draw. I'm scribbling tonight, and that's the police car outside. Oh, hello. Just popped right in. Oh, did it happen? Alright, there we go. So, right now, if we stack the carbon piece on top of the base there, we got something like that. and basically there will be a gap between them. Yeah. So how do we get rid of that gap? Well, they usually come in the form of something that is extended through like so. So this can be attached either to the carbon base, the carbon part there, or alternatively, it can be attached to the base itself, like so. But it needs to be consistent all around this rim here. And the problem with doing it on the base is that we have to have this hole accessible so that we can put a fan in. So I don't think we can do it on the base. We have to do it on the funnel side. No, not funnel side, god damn it. On the carbon basket side. At best we can do that. But the problem with the carbon side is that you have to print it on that side. Because if you imagine something like that. So this is going to be on the bed right there. So you need to make some. You need to basically it necessitate the need for support there, and these two little slots for the carbon basket side, which is annoying. But I don't think we have much choice. Yeah, the carbon basket, what I want to do with it, I want to print it without top and bottom. So basically just infill we create a mesh with 3D printing within the slicing. So that's what I'm going to do with that one. Alternatively, we can make this connector piece a separate item. Alternatively, we can make this connector piece a separate item. Oh yeah! We could do that. What time is it, by the way? Oh, it's 5. It has been 5 hours and a stream. Anyway, where was I before I go crazy and forget what I was doing? Maybe we should just make it now and then fix it later. No. No, let's not do that. It's been too long. So what I'm gonna do that tomorrow, and I'm gonna write it down as a connection piece, separate connection piece. Connector piece. Between base and filter, and then carbon. Yeah, we can write that down so that we remember to do it tomorrow. But that is it. Oh my god, it's been such a long day. So we don't need to do anything here. Actually, if anything, we might want to cover up these so that they don't. It's pathetic. Does it look good? Actually, it doesn't look too good. The surface here. Look. I take it back. You don't get to be transparent. Yeah, that's just it for now. All right. That's it. I really should have asked people to like and subscribe more often, huh? Because out of the 174 people that had joined at some across the channel, I had only 2 likes, fortunately. Well, I can't help it. At some point, your brain just kind of shut off and just focus on the thing that you want to do instead of trying to run a stream. So, chat. That's it for me. Thank you so much for the few people to join in and watch the stream. Once again, I'm pretty sure this is a boring stream. I'm not planning to make this my job or anything. That's why I'm happy to keep it boring. And if anything, it allowed me to just allow me to record, and I forgot to record the stream. Okay, so it allowed me to have a means to keep track to an option at least to keep the footage of what I have been doing, like how I've meshed with the cat on tape, so that if I ever need this footage, I can use that again. But nevertheless, it's been nearly 6 hours, 5.5 hours or something. Oh, wrong button. Yeah, it's been 5 hours and 15 minutes. I am and it is 11 o'clock in the UK. So I'm gonna go watch some anime and just hit the bed, and I'll see you tomorrow. Bye. I need an end screen.